Okay, let's officially start. I think everybody here knows us, and so I'm Mike. I'm the lead mentor for Hyper Droids. Adrian's our team lead and designer. So today he's gonna teach you OnShape for FTC. So we're also gonna build a parallel plate drivetrain this afternoon, I
Yep.
believe, from scratch. So the first bit here will be some presentation, some talking. You'll have a couple breaks for some little exercises and stuff. We'll have about a half-hour break for lunch. There's if anyone doesn't know the layout of the university, come ask me. But there's some food options, or we can eat in here, or whatever. So we'll take a little break for lunch, and then we'll do the parallel plate drivetrain stuff this afternoon.
Yeah.
And Sheldon, I think, will be coming this afternoon to help with some of the OnShape stuff. We have Edgar here, who's president of ATAA. So if you guys don't know Edgar, I think you all do. So yeah, we'll get going here right away.
Yeah. Okay. So yeah, OnShape for FTC. Hopefully you're all here to learn OnShape. If you've used Fusion or SolidWorks before, it's kind of similar. Some of your skills should translate over, especially from SolidWorks. Table of contents. What are we going to be going over today? So I'm going to start with like some design principles. So kind of stuff to think about before you even start doing anything in CAD. Stuff to think about at the start of season when you're thinking of a design for your robot. How to progress forward with that. We're going to go over OnShape basics, so basic controls, some useful tools and stuff that I have for OnShape. So some of you have already seen those. And then we're going to go over competitive drivetrains. So what drivetrains do most people run in FTC and why? So, and then kind of how to design some of them. We're going to go over lifts and linear slides. This is where I see most, especially teams in Alberta, this is where I see a lot of problems with like certain design choices or certain aspects of your robot design not coming through completely with, especially with linear slides. There's a lot of different options out there, and a lot of teams struggle to like get them working properly. We're going to go over step-by-step drivetrain. So I'll lead you through how to build a drivetrain from scratch, from the bottom up. We'll go over feature scripts. This is a unique OnShape component that they give you the ability to do some like more custom stuff. They make your life a lot easier, especially when you're doing more complex things like with gears, belts. We'll go over those, and that kind of leads into, so I have a couple challenges for like how to modify the drivetrain, how to customize it more towards your team, and further projects that you can do after today. So start with design principles. So why am I teaching OnShape instead of SolidWorks or Fusion or whatever? So OnShape has a couple key benefits for FTC teams that I think really improve like the workflow and really improve your team dynamic when it comes to CAD. So first of all, OnShape is accessible on any device, including your phone. If you really hate using a mouse for whatever reason or something, don't use it on your phone. It's not fun. But technically you can. OnShape is mostly, the main reason it's super nice is you can access it from anywhere. It's kind of like Google Docs. As long as you have Wi-Fi, you can connect to it, and you can edit any of your documents. So it's super easy. You don't need to have like a USB stick with all of your CAD designs on it that you carry around with you at all times. And it's really easy to share like files from one person to another. OnShape is also the most popular CAD platform for FIRST robotics. So especially in FTC, there's a lot of designs out there already that you can use or kind of take inspiration from. There's a lot of tutorials for OnShape, specifically for FTC. There's really good documentation. FRCdesign.org has really, really good documentation on using OnShape specifically for FRC or for robotics, but it translates pretty well into FTC. Yeah, so OnShape is what's called a parametric CAD. So that means if I go here, it's kind of built, everything builds upon itself. So if I go to this feature menu here, this is a little messy because this is like our first CAD, but we have some base sketches here, and all of the rest of the geometry of the robot plays off of these base sketches. So I can adjust parts of these base sketches, and everything following it will change. I don't need to go in by hand and change like all of the plates to be like whatever 10 mils shorter. I can just change it in one of these base sketches, and everything else kind of shifts off of that. So that can be a struggle if you're like, if defense or little defense. So for FTC, the way you win the games is you need to score more points than your opponent, obviously, but the way you do that effectively is with really fast cycle times. So compared to something like FRC, where you can have an effective robot that isn't necessarily the fastest at cycling, but it can do one thing really well, whereas instead of doing like all of the things, in FTC, you really need to be able to cycle on every aspect of the game, and you need to be able to do it extremely quickly. So especially when you're analyzing a game at the start of the season, you need to identify aspects that will score you the most points. You need to identify aspects that you can score points quickly. So this year, a lot of teams realized that the basket, while it's worth less points than a specimen, it's going to be a lot faster to score because you don't need to cycle it to the human player and then bring it to the chamber. You just go directly from the submersible to the basket. So identifying aspects like that and trying to target them in your design really improves the efficiency of your robot on the field just from day one, as well as improves kind of like your overall like game strategy. So for your robots, something's going to break. Something always breaks. You never have a season where you build a robot and it just like works the entire time and nothing breaks. So I find having subsystems on your robot, so splitting your robot into different sections, so like say a drivetrain, lifts, end effectors, and kind of keeping those in their own like sort of section of your robot, section of your mind that really allows you to build like before you can score something in the basket, you first need to be able to drive there. So what do you need to build first? You need to build a drivetrain. Before you can pick up an element and score it in the basket, you need to have something to raise the element up, right? So kind of have the subsystems build off of each other and go from what you need at the start, like what you need to do anything at all in the game, and then kind of moving up from there. It gives you kind of a sense of what needs to be really, what needs to be really robust and what needs to be really well thought out on your robot versus what you can add later to improve like minor aspects of the game. Keeping the subsystems modular. So for example, on this year's robot, we were able to detach our entire arm system using only 2 bolts. We're able to attach our entire claw subassembly using only 2 bolts. So it's still pretty robust, but it allows you to say, oh, we broke this claw, we can just put a new one on, or we can take it off and work on this while we put like our old one on or something like that. Being able to quickly make fixes and repairs on your robot is really critical, especially in a competition. Sometimes you only have like 15, 20 minutes between matches. You need to be able to like kind of adapt to that situation, and having a robot that's designed around being modular and being repairable really helps with that. So costs. Keeping costs low especially on FTC robots can be a little challenging. So one thing I find that helps keep costs super low is you need to, like I said, you need to focus on kind of the base aspects of like, oh, what do we start with? What is the bare minimum we need to build an effective robot this season? So, and then kind of like distributing budget as it's needed for starting with those critical subsystems first. So you don't need to spend $180 on servos for your end effector if you're not going to be able to, if you don't have a lift, right? So you got it. Spending the money on stuff like drivetrain, stuff like elevators can be reused season to season. Spending more money on those and keeping parts from previous seasons moving into the next year's robot really helps with that. The other thing that helps keep costs super low is even a little bit of 3D printing thrown onto like an off-the-shelf robot can make it really, really effective at a pretty low cost. So a lot of teams this year were running kitbots of some variety. I saw there were several kitbots at provincials that did quite well. A lot of them were only very lightly modified versions of the original kitbot. So using a little bit of 3D printing here and there and kind of targeting it in an effective area, so an area where the kitbot parts aren't super effective, can really improve your design. So like, for example, this year, the Go Build a Drivetrain, or like the Go Build a Kitbot, the arm was not able to reach all the way up to the basket. So teams implemented, like I saw one team used rev linear slides on the Go Build a Kitbot, and they were effectively able to score in all areas of the game just with a little bit of modifications. The other area that the Go Build a Kitbot was really weak in was picking up game elements from the submersible. So a lot of teams adapted and added like a simple 3D printed claw or 3D printed intake onto that, and that really improved the effectiveness of it at very low cost. And it's a nice spot to like devote your design skills to kind of saving money but still improving performance on your robot. The other one that I've highlighted, this is one that our mentor, Mac, really likes to highlight. Driver practice is always going to improve your performance on the field, no matter how good your robot is. It doesn't matter if it's a push bot. It doesn't matter if it's like whatever. There's like 3 subsystems. You're doing like automated transfer. You have a swerve drive. It doesn't matter. Driver practice will always improve your performance on the field. So if you're sitting around and there's like, oh, we don't have time to redesign the robot, our programmer isn't here, pick up a controller and drive the robot. And getting like even like an extra like 2 or 3 hours of driver practice and talking over like strategy can really, really improve how well your robot performs without needing to change anything. Like I saw push bots in like qualifier matches who were winning games against robots that could score like 2 or 3 specimens in auto just because they were really well driven and they got in the way. They took game elements where it was critical, and they were able to kind of, even though they were just able to push around game elements on the field, they were able to disrupt kind of the field of play enough that they were able to achieve more, like score more points than their opponent. So just getting like any amount of driver practice whenever possible really, really improves how you can perform at competitions. We're gonna move into more of a like some actual hands-on stuff here. So we're gonna add a bunch of tools that we're gonna use today in OnShape. So everybody go over to 10015.ca. If you've already done this, it's fine. Click on this parts library. We're gonna open that, and we're gonna open this link here at the top, as well as watch, like if you only have 10 mils of space on your drive like to put the pulley in, and you set this to 10 mil, it's gonna be like we can see here, it's actually 13 mils. So this is the width of your belt. You can select the type of bore you want on the pulley. This is super useful. We use these all the time on basically all aspects of our robot. So yeah, what you're gonna want to do, you're gonna want to click here, make a copy to edit, put it in somewhere where you can access it. So I'll just put one here, say copy here, and then now you'll always be able to insert parts from this once it loads. Wi-Fi might be an issue here. Yeah, you'll always be able to put parts from this document into your other CAD assemblies. The other one, we're gonna want to go grab. This link should send you to the App Store here for OnShape. You're gonna want to subscribe to this insert tool. So this gives you access to all of the off-the-shelf parts from Rev, GoBuilda, AndyMark, Studica, whoever. It also has links to LuniLib and a couple other little more niche parts. So if you weren't able to do that, well, yeah, I guess, does anybody have issues with that, or are we all mostly set?
So is that suslib
Yeah.
only for gears?
It
like
does.
Where do you choose the type of?
So here, I'll show you in a different document. So let's go to this document here. So I can so if you want to insert parts from that in a part studio, you'll go here, you'll click on this, where is it, derived. So derived grabs like 3D geometry from another part studio in any other document. So you'll go select part studio here, other documents. Yeah, so configurable parts copy here. So you can select any of these part studios you'll be able to grab stuff from. So let's say we want like, I don't know, we could do a bevel. So bevel gear here, 24 tooth, partner teeth, let's say 30. Shaft angle 90 degrees, width mod, probably want more like a 3 mil here. Pressure angle, spiral angle, generate, and then should have a gear in here. This will also do like the screws and the MGN rails are a little like less useful. Like screws you can just insert from the like OnShape's default parts catalog, but you can do all of those from that document. Somebody had a hand up over there. No? Okay, good. Okay, we're gonna just go over how to use that insert tool real quick. So insert tool is the, oh, the edge of my screen is clipping. Insert tool is for all of those off-the-shelf vendor parts. So if you're in a document here, go click on your assembly, and then all the way over to the right, this insert tool. Wait for it to load. If this is your first time opening it, you'll have a bunch of text to read through, and then like you'll have to hit agree, and then it'll read through some documentation. There should be a little folder icon up here. So if everybody clicks on it's not here for me, but if you're in that text block, the like starting thing, once you click on that little folder icon, you should see this menu. Go to this global libraries tab here, and then you have all of your parts vendors. So you can insert, I don't know, anything you feel like really from any of those catalogs. If anybody's having trouble with that, let me know because we will be using this quite a bit today. Okay, 1 second. You're not in an assembly, that's why. Yeah, so there you go. Okay. Try reloading your page if you added it successfully. Reloading it does, sometimes you need to reload the page. I guess I should have said that. Yeah, there you go. You're also in a part studio, not an assembly. So down at the bottom, click on the assembly. Also, maybe try reloading your page. Okay, yeah, so you have to, yeah. You should be able to click on this folder icon up here, and then, yeah, global libraries, and then you should be good to go. If you, did you add the tool successfully? No. So go to 10015.ca. Just like type it into a web browser. No, like in, yeah, web browser tab. Is anybody? Okay, we have two. Oh boy. Yeah. 15.ca. Yeah. And then click CAD. Click parts library. And then subscribe to it. And then you should be able to follow the rest of it. Yeah. The cyber. Oh, okay. So you need to make a new. Go into make a new document. So go OnShape, just like the OnShape. Yeah, there. So go assembly. So the reason you can't access it in a part studio is because try reloading your tab. This inserts like fully completed parts, which you can't import into part studios. Yeah, should see it down there on the right here. Yeah. Same deal, just go to an assembly and you should be good to go. And then, yeah, right here. And yeah, you're good as well. There you go. Okay, is everybody, oh no, one more. Doopa-doopa-doo. Yeah, that one, and then if you have the, yeah, OnShape App Store. Okay, so yeah, you're in assembly, so good. So click on this guy down here, and then yeah, should be global libraries, and then you're good to go. Is that, yeah. You're in airplane mode, I think. You might, yeah, you're gonna need to connect to the Wi-Fi. Or it looks like you're not connected. I don't use Windows, sorry. I guess everybody in the stream can hear me with the microphone. Okay. Is everybody good now? Maybe. Hopefully. No. Parts library, yeah. Yeah, and then you hit subscribe. Here. Why is it grayed out? Oh, you're not signed in. That's why. Yeah.
Is it possible to make the screen a little brighter?
Maybe. Let me. Yeah, that's fair. Dad, can we make the screen brighter, by any chance? And or dim the lights, maybe. Doop-a-doop-a-doo. Okay. Global libraries. That one. Your mouse is weird. Okay. Click. Wait. Go up. Scroll all the way down. Oh, wait a minute. Should be able to go. Okay, click on the home. Yeah. There you go. Yeah. Okay. Okay. I'm gonna go over it real quick. Do you want me to turn more lights off, or are we okay? I'm gonna go over it once again real quick, just for everybody. So make sure you're in an assembly down here in a document. Go all the way over to the right of your screen. You'll see this little insert tool tab. Click on that. Wait for it to load. Click home, global libraries, select, I don't know, your favorite robotics vendor. And then you should be able to select any part you want. So like, I don't know, let's insert an old strafer chassis, I guess. There we go. You can close that, and now you have a thing in your document. Great success, maybe, kind of, sort of. Okay, I have at least one thumbs up. I'll take it. That's probably too many lights. Okay. That is most of the. That's basically all the resources we'll be using today. Obviously, there's more links on the website here if you want to go over some of those. I'll talk about them after. You can come and ask me about them. This FRC design one is really good for like a learning course for OnShape, and some other just like good tips and tricks. Feature scripts, these are always useful. And then the miscellaneous, these are mostly like help resources. So this is places you can go for like questions or stuff. Yeah. OnShape organization. So basic controls, and I already talked about what is parametric CAD. I want to talk a little bit more about, like, before we even make anything, I want to talk about how to organize documents and kind of how version control and stuff works in OnShape. So in case you really mess up, how do I undo all of my mistakes so I can get back to what I had before? So for OnShape, the way I like to organize it is you can make folders here and put documents in the folders. You can put more folders in the folders, kind of basic file organization stuff. The one thing you do have to be a little bit careful with is, let's say I'm in a classroom. If I accidentally create documents in Owned by Me here and then link them into this classroom. So for example, if I have my robot CAD here and I've inserted something, like let's say I go to our final robot CAD and I insert a part that's from a document that my account owns, nobody else on my team will be able to modify that part. So they'll still be able to move it around in this document, but let's say they need to change the geometry of a part that's in one of my, like, Owned by Me, like, section, they won't be able to change the geometry of it. So make sure you have all of, like, your robot CAD stuff or your team CAD stuff in your team folder instead of in just, like, your personal section, because it will still let me, like, insert stuff from my personal, like, right, I can insert, like, I don't know, this here. So in terms of how, this is a bad example, we're going to go to my prettier drivetrain, this one. In terms of how to organize stuff inside a document. So almost all of your kind of like actual like CAD or like actual like making custom parts will happen in a part studio. So part studios are where you make custom features. It's where you make sketches, and you basically start with 2D geometry and you build your way up to 3D geometry. I like to try and limit part studios to kind of one section. So here on this drivetrain, this is my plates part studio. So this has nothing except for drivetrain plates. If I wanted to say make like an odometry mount or like make a 3D printed part or like something like that, I would make a new part studio and then derive. So kind of the basic part studio workflow here is you make one. So I'm getting ahead of myself. Wow. I'll talk about that later. You want to start part studios, kind of limit them to like one subsection. You don't want to have one part studio that has like all of your stuff in it. It gets really messy and it slows down your computer when you need to edit. Like if I want to edit like just this drivetrain plate, I don't want to have to also render all of the rest of the robot stuff. For assemblies, you know what?
Terrace asking on the stream.
Yeah.
Just how to get access to the parts library. We just stop. Make sure everybody else has parts library access.
Yeah. So for parts library access, you're going to go to 10015.ca. Click on this parts library link. App Store here is what it will take you to. You want to click on subscribe, which will be here instead of cancel plan. Once you've subscribed, you should have access to that parts library.
And you may have to refresh.
Yeah, you may have to refresh like this tab to be able to see the insert tool. Yeah. Okay, so version control and linked documents. So for version control, OnShape saves complete version history. So everything you do, like if I drag stuff around, like if I drag this battery and you go here to this versions and history, show change, I can see this drag instance. So it saves literally everything. This is super great for if I like I can do this. I get like, you can, so this is great for like, let's say I want to restore like something that I did in the past here, like, oh, I messed something up. I can go down this list. I can find approximately where I think the changes. You can click on it and then you can restore it to, you can create a version here and then restore that version to your main branch. So this kind of works similar to GitHub where you can create like versions whenever you make like a major change, and that will bookmark like a spot in this version. So this is a bad example in I have not created any versions in this document. But if we go to, say, Trident here, we have different versions. So these are kind of bookmark spots in like major points in the design. So I like to create one whenever I make a major change or whenever I say order parts. So here you can see I have created a version on one of our send cut send orders. So this is a plate machining service. So I know this is the geometry of the plates that I have like a physical copy of on the robot. So creating versions here can make this kind of bookmarks like major spots in your design. And if you need to go back to a previous design and like branch off of that, this is a really easy way to do that. You can also create branches here. So let's say I have like, I'm working on a claw and somebody else on my team is working on an active intake. They can create a branch and start modifying stuff. And then let's say we choose the active intake in the end for our final robot design. We can merge the active intake branch back in, and that will become the main robot design. The other thing to be careful with, so this is kind of a bad example because I didn't know better when I started making this. So this has a bunch of stuff that shouldn't be in this assembly, but you'll notice that, where is it? Here. So if I click on this, this highlights our entire box tube arm assembly. So this is one insert of another document. So this is what OnShape calls a linked document. So the way these work is if I have like a finished like elevator design, I can insert the entire elevator straight into this final assembly on my drivetrain, and that leaves me with a nice clean, just one. So ideally, I did this wrong. So ideally, your final assembly here has like one insert for each of your assemblies. So you'll insert a drivetrain you'll insert an elevator, you'll insert a claw, and then it's just 3 items here and nothing else. The reason that's better is OnShape renders solid assemblies as one piece. So my drivetrain has no moving components on it. I didn't animate any of it. So if I insert my drivetrain, it renders as just a drivetrain and nothing else, and that really, really improves performance on my computer. So instead of, right now, it's rendering each of these things separately, and that's really tanking my, well, my laptop's like has decent specs, but it can, like, I've seen it, the computers we have at the build space, for example, struggle a little bit. Some of them do with like this assembly. The other thing to focus on is when you link documents, so this elevator, if I go and make a change in this box tube elevator CAD, so where's the button?
Can you make those fonts bigger for the display, or is that kind of fixed?
Yes, but I don't want to. If I go and open that, if I go and open this box tube extension here, and let's say I make a change like so this is a good example of what you want a final assembly to look like. Sorry, I'm like hopping all over the place. So I have one insert for each of our kind of final parts here, and then this becomes just a nice clean final assembly. If you want, like, let's say I make a change in this document and I like, I don't know, delete our claw. So this is gone. If I go back into here, you'll notice this is a linked document. So let's say I reload the page. It's still here. So the reason this is when you, in OnShape, when you update documents, if they're linked, you need to hit it. You need to make a new version for these changes to show up in any upstream documents. So make sure, especially, there we go. Make sure, especially when you have a lot of different subassemblies on your final robot, you need to hit this create version. So as you can see, I've done this a lot on this thing. I have 23 versions already. I'll create a version here. I'll go to this, and then I hit this update linked documents button, and this will update all of our linked documents. And then now you can see the changes of update, and we do not have a claw anymore. So that's kind of your basic workflow for OnShape goes. You go Part Studio, multiple Part Studios become an assembly. Once you have multiple assemblies, you put them into a final assembly, is what I generally call it. So a final assembly, in every document, that final assembly will have your fully completed mechanism for whatever that document is for. So in this case, it's a full robot. In this box tube extension case, it's the final elevator with everything added. Once you have that final assembly, then you can take all of your final assemblies from all of your different subsystems, put them together into a robot. That's kind of your basic OnShape workflow. There's a couple little like things that you change here and there, but that's essentially how we start. Permissions and sharing. Pretty simple. There's a big old share button up here. By default, if it's in a classroom or a folder, it will be shared with everybody that's on that team. So for example, everybody who's on Hyper Droid can access and modify this document as an editor. Because I'm an admin on our team, I can change that so I can make them all only able to view it if I want. By default, if you do not have an education subscription, anybody who has OnShape can find and look at your document. So yes, sure, somebody could steal your design, but also there's like hundreds of thousands of documents on OnShape public, and nobody digs through all of them. It will be it will be non-public by default if you have an education subscription. And what that means is if I send this link to somebody and they don't have access to it, they'll just see like you don't have access to this, and it'll redirect them to the OnShape homepage. So if you want to share this with other individuals or like other teams, the best way to do it, I find, is to turn on link sharing. So I have link sharing on this, so anybody with the link to this document can view it, and I have experts turned on. So there's a couple different ways. With experts turned on, I can send this link to anybody, and they can make a copy of the document for themselves and start modifying it. I can turn exports off, so it can be view only. So I can send a link to somebody, they can look at my design, but they can't copy the workspace. So there's a couple different ways to share designs, like if you want to share designs with sponsors, if you want to share designs with other teams. There's a couple different ways to set it up. Choose which one works best for you. So you can see here, this is a public document. So as the creator of this document, I can see who else, well, I can't see who has made a copy of it, but I can see how many people have made a copy of it and how many links of this document there are. So 8 people have a copy of this document for themselves. So 8 people have like taken this and maybe modified it or just looked at it. There's 47 links of this document. So 47 different, I believe this tracks IPs or something. 47 different IPs have basically visited this link and looked at the document. All right, moving on. We're gonna do a little bit more hands-on stuff here. We're gonna talk about configurations. So this is another OnShape thing that allows you to make modular parts that are usable in multiple circumstances. We're gonna talk about sketches. Sketches are basically your bread and butter of OnShape. And we're gonna talk about some Part Studio controls. So let's have everybody go. I'll open up this test document. Let's have everybody open up this document that you made. We're gonna go to our Part Studio here. Should get rid of this. Okay. Yeah. Okay. Like right now. Okay. So once you're in here, I'm gonna go over some like super basic controls, and then we'll get into sketching. So for most of you, when you created your OnShape account, depending on what controls you set, like if it asks you like what you're most familiar with for CAD programs when you create your OnShape account, your controls will be a little different depending. So if you selected SolidWorks or Fusion like I did, I believe what it will be is your left click will be select. So this can select stuff in your studio. Your right click and drag will be like rotate, and then middle mouse will be pan. You can also always use your view cube up here to reorient yourself, and you can change your settings if you don't like them in your like account settings. So up here, my account, and then somewhere in here, preferences. So you can change default units, mouse controls, and stuff in here if you don't like them. I highly encourage everybody to set your default units to millimeters with 3 decimal places. This is pretty standard. Almost all of the off-the-shelf vendors have technical diagrams in millimeters. This is really helpful. It's nice to remember that in OnShape, you can always type in, I guess I'll get to that later. Never mind. So in your Part Studio here, we're going to see a couple things. So on your left, you're going to have your feature menu. So top to bottom, this is the order that features are generated. So for parametric CAD, that means the origin is generated first, then our top, front, and right planes. This does mean that, if I have a sketch and I want to reference that sketch with something, the sketch must be above the extrude, say, that I'm referencing it with. So we'll get into that a little bit more later. But sometimes moving stuff around on your feature menu can influence how the geometry plays out in your render window here. You have a parts list down here. So every time you make a new piece of geometry, it will either make a new part or be part of an existing part, and that'll show down here. On the bottom, we have our like studio menu. So you can create new part studios and new assemblies from this, as well as folders and variable studios and imports. Okay, I'll go over, so there's kind of 2 toolbars here. Sketch is going to be your first one. So if everybody clicks on the sketch menu up here in the top left, you'll see this box show up. Let me make it bigger. Okay, so yeah, this screen isn't great. When we create a sketch, the first thing you need to do is you need to select a plane that it's going to be on. So sketches are 2D geometry. they only exist in one plane. To make them 3D, you have to use like extrude or some other tool in the Parts Studio menu. So I'm just gonna select the top plane here, and now you're gonna notice our toolbar has changed. So for basic on-shape controls, this is the toolbar that you'll probably be spending the most time looking at. You're gonna have kind of 2D feature like generating stuff over here. So lines, rectangles, circles, arcs, polygons, splines, points, text, and this use. So use, also known as project. This allows you to put geometry from other stuff onto this 2D plane that your sketch is on. This tool is super useful. It lets you like avoid having to like redraw your sketch out if you want to make like a second, like a very similar one, something like that. Yeah.
Can we just take a like a 2-minute break? 5-minute
Yeah.
break. So I noticed at least one person has been in the bathroom. So just the bathrooms are kind of behind us here. I drew a little map here, but just down this hallway and then left, and you'll see signs for the bathrooms. And then yeah, can we also just make sure? I know like Adrian's having problems with the parts library thing. I know one person in the stream was.
Okay.
Is anybody else having problems getting access to the parts libraries? Okay. Do you mind just quickly helping me with it? And
Yeah.
And then yeah, if you need to go to the bathroom, maybe now's a good time to take a quick break here. And then yeah.
Yeah. You need to make sure you're in an assembly first. Yeah. Bottom one. Oh, can we not do that? Isn't okay.
So you can just pick one of those. Like you can just browse around.
Yeah.
When you click on a part, they'll add that part.
No, you cannot access my team's stuff. That's the like the 10015.ca has links to like public resources that everybody can access. The stuff in Hyper Droid's like classroom is basically just copies of the public documents. Yeah. Yeah. Is anybody else having issues? You need. Okay, so you deleted your Part Studio when you made this. So insert new tab here and then create Part Studio. So now you have Part Studio here, and you can see the sketch menu there. So yeah, yeah. And if you want to play around, so if you want to play around with like line tool, like these will make like basically just basic shapes in your sketch. So like for example, if you click on the circle tool there, and then like click somewhere and drag, you'll have a circle. Yeah, and then click again to confirm. So whenever you see a text box that's white like this, that means it's waiting. Oh, you clicked on it. Yeah, it's waiting for some like dimension to be applied or like something to be typed in. So if you click again and then just type like a number into your keyboard, it'll make that circle. So now that circle is 110 millimeters in diameter. So whenever you see like a white circle like that, it's basically waiting for like some like text to be input into it to define geometry. And then if you want to edit that, you can double click again. Or yeah, sorry. You gotta When you see it, it glows orange. You click on it twice, and then you can edit the. So let's say you could change it to be like 10 mils or something, and then you'd have a 10 mil circle instead, which is very small. So if you click outside, yeah, oh yeah, now you selected that. But yeah, it's kind of finicky, but once you get used to it, it's pretty easy. Yeah. Okay, does anybody else have questions or whatever? And Dad, is that thing working? Is the thing that?
That is working. So I'm asking the stream if that's better. But so now, Adrian,
Yeah.
if you want to see, this is what I now have you in the corner, and like that screen is being shared via Jitsi to me.
Okay, so they won't be able to see slides then, right?
Yeah, when you go to slides, I'll switch to slides and show you.
Oh, right. Yeah. Okay. Is everybody good now? No? No. Jaden, did your laptop die? Oh.
I have some space here. If you wanna sit, move your chair here. There's some space in the back of the screen. Is that what?
Come sit here and plug in.
How are we doing for time? Bruh. Okay.
Our outlets are. Sorry for making you guys. Those lights, at least one of those isn't working, but the ones over here are working.
Yeah, I kind of expected this. You look super engaged.
And I think the ones back there are working
You
too.
look excited. Yeah.
So here, I'll go to them first. Just, and then I'll pass it right here.
Yeah, yeah, it's fine. I got the charge, so maybe you put it behind. Yeah, like that. Probably the easiest way.
Okay, once Jaden gets his laptop back in, we're gonna start going over sketches. If at any point I'm like talking too fast or going too fast and you get behind, like please raise your hand or like say something to me. Same with people on the stream. If you get behind, it's a little more difficult for me to help you guys out, but say something and I can try and help you out with that. Okay. Okay, so I'm gonna really quickly go over all of our sketching controls. So these are probably the most useful tools you have in a part studio. This allows you to make all kinds of different 2D geometry. It allows you to define, yeah, in the washroom. Okay, yeah. I can wait then. I'm gonna blow a fuse.
I was gonna say that's what mine we blow the sleep.
UFC will be happy with this, right?
Are they charging us for power? Haha.
They're not charging us for power.
All right, sweet.
What's Randall with this one? In this room for the day?
That's why we're.
Okay. I think everybody's back now, so we're gonna start with sketching. So if you've used OnShape at all before, you're probably at least somewhat familiar with this menu. But I'm just gonna go over it real quick. So starting up here, we have our line tool. So if everybody selects this, I don't know.
Do you guys want the lights on or off back here?
You can take it off.
Okay. I know this deck is not.
Yeah, we're just trying to move things around.
What, for practice, what are we trying to sketch?
So I'm gonna go. We're gonna sketch a configurable spacer. So it'll basically be like 2 circles to start in the sketch. But I'm gonna go over all the tools so that everybody kind of knows what they're looking at here. Most of the tools we'll be using circles. Circles are cool. Circles get used a lot. Circles, rectangles, and this center point arc are going to be kind of our 3 tools that we use the most here. So I'm gonna like the line is pretty self-explanatory. We're gonna make a we're gonna make a circle in the center of our sketch. So you notice I select the circle tool, or you can press C on your keyboard. There's hotkeys for almost all of these. Some of the weird ones don't have hotkeys. I believe you can configure all of them to have hotkeys if you want. But anyways, C or click up here to select the circle tool, and then we'll make a circle. So you click once and then drag, and you'll see a circle. In OnShape, whenever you see one of these white text boxes, that means it's waiting for you to type something into your keyboard. So you don't need to. You can just click somewhere, and the text box will go away. If you want to type, so this is going to define some geometry related to the circle. So in this case, it's going to define the diameter of the circle. So if we're making a spacer that we want to fit on an M4 screw, which is probably the most common hardware type in FTC, my first instinct would be to make, okay, let's make a 4 mm diameter circle. We'll talk about tolerances a little bit later, but I find for 3D printing, to have a nice clearance fit, you want at least 0.2 or 0.3 of a mil of clearance because of the heat expansion of the filament. So pretending this is a spacer that we're actually going to use, I'm going to make it 4.3 mils in diameter. As you can see, that's actually pretty small. So if you clicked away and that text box went away, instead of defining it when you start, so anything that's blue in OnShape means that at least one or more of its constraints are not defined. So for example, this circle is blue because not only is its size not defined, I can drag it around, its location in the part studio is also not defined. So generally speaking, you never want to see blue stuff on your sketches. If it's blue, that means it's not defined. That means it's just kind of arbitrarily been placed in space, and you don't know where it is relative to the other stuff. And if somebody comes in and is like, oops, I accidentally dragged the circle, your entire design could be messed up and you don't really know because you haven't defined it. So all of the stuff on the right here, so starting from coincident over all the way to this curvature, these are geometry defining features in your part studio. So the most common ones we'll be using are coincident or I on your keyboard. This makes two entities kind of like in the same spot. So if I go coincident on the center of the circle and the origin here, it will lock its location to the origin. So you'll notice I can't drag it around anymore. Its size is still defined, or undefined, sorry, so I can drag it to be any size that I like, but its position is locked in space. Coincentric is similar, but it makes it coincident with the center of a circle or a curvature. So if I wanted to put like a point in the middle of the circle, I could use that to lock the point to the center of the circle. Other ones are pretty self-explanatory. Horizontal, vertical, exactly how it sounds. Equal is useful for making two things equal in size. So let's say I make another circle. I make another circle here, and oh yeah. So the dimension tool, this one you use the most probably. It's D on your keyboard. This allows you to define distances depending on what you click on. So in this case, I've selected the diameter of the circle, so I'm going to define it to be 4.3 again. So, oh, there's another circle here. Now we have a 4.3. Where'd the other one go? Oh, it's right there. So now we have a 4.3 diameter circle. Let's say I wanted to make another 4.31. Instead of dimensioning it and typing 4.3 in a second time, I can hit E or equals on my keyboard and select the other circle, and then we'll have two circles of the same size. And this is super useful. I really encourage people to use the equals tool as much as possible, because let's say I have like whatever 10 screw holes on this part that I'm designing, and I decide to change I want to change the tolerance on the screw holes from 4.1 to 4.2. Instead of, if they were all dimensioned separately, I'd have to go in and type 4.2 into every single circle to change it. If we're using this equals tool instead, I can just change the diameter of this one circle and it will update all of them. Okay, so everybody, let's just make a circle that's 4.3 mils in diameter here. So once you have that in the center of your sketch, you're going to go and make a second circle around it. So C or click up here to make a circle. Click on the origin or the center of that. When you're creating geometry, so you'll notice like as I hover here, it's maybe kind of difficult to see, but you can see this little horizontal or vertical icon pop up. That means it's going to automatically define certain parts of your geometry when you start the circle. So here if I do this and click, because I clicked on that line when I started the circle, it's now coincident to this other one, so it moves with it. So you do need to watch out for that. Like sometimes it's super useful, right? You can just click and kind of like it automatically defines stuff for you. But sometimes if you're like making a line or whatever and it accidentally defines something that you don't want, it'll become overdefined when you actually like adjust it later. anyways, we're going to dimension this circle. So this is going to become the outside of our spacer. So if the inside is 4.3, I generally like to keep spacers at least 2 mils or more thicker. So in this case, let's make it a 7, the outer diameter of 7. So now you'll notice there's like a darker gray area here. This means this is like a fully enclosed area, and that's important because anything that's fully enclosed means I can extrude it into a 3D geometry later. So if you want to change the dimensions of the spacer, you totally could. We're going to make them configurable in a second anyways, so you'll be able to update them when you put them into a document. Yep.
So I had my default unit of inches when creating this.
Yeah.
And then changed it to millimeters afterward. The
Yeah.
units are still displayed as inches. Is the properties for per document?
Yes. Document properties are up here. Yeah, document details are it's workspace units. So if your default setting is at inches when you create the document, it'll make the workspace details as inches. The other useful thing about OnShape is when I go to dimension something or whenever I'm typing units into a thing, I can always manually type in. So if I just type in a number, my default is millimeters, so that's what it'll set it to. If I want it to be inches, I can say 1/8 and then I type in inch and you'll see it'll select this, and now that's 1/8 of an inch. You can always type in inches manually, even if your document is in millimeters, and it'll convert it to millimeters for you. So this can be useful when, say, designing like, the sizing constraints for FTC are 18 by 18 by 18 inches. So instead of converting that to millimeters separately and then typing the millimeter number in, you can just type in 18 and then IN, and it'll convert it to inches for you. You can do the same with like radians versus degrees and stuff like that. So once we have these two circles here, actually, I'm just going to real quick show a different way to do this. So there's always two ways. Well, there's always a couple ways to define stuff, especially in CAD. So instead of, say, making this circle and defining it as like a separate dimension, I could also, say, use this offset tool or O on your keyboard and make it an offset from the first one. So this gives us a similar result with different different tools. There's always going to be different ways to do it. It's kind of up to you to select like what you think is the best option or what you're most familiar with. At the end of the day, you're still going to have two circles. Cool. But yeah. So that's kind of your basic sketching controls. It can get like significantly more complicated than this. So like, let's say I go, what's like a really annoying looking sketch? Like some of these sketches can get pretty complex. Where's the big one? This is also a bad example because I don't have any of my sketches named properly. You can always rename features, and I highly recommend that you do so. Yeah.
How come they're blue?
All blue? Okay, so that's because we have stuff like this is just an arbitrary this is just a box that's the size of a sample that somebody's put in here. So blue, this little blue icon here, that's a good point. That means that something in the sketch is undefined. So most of the time, if you see that, that's bad. That means something is undefined, but in some circumstances, it's fine. So like, for example, this sample, we're not actually using any of the geometry of this sample. It's just here for reference, so it doesn't need to be, the size of it is constrained. It's just not constrained positionally. Right, you can see I can slide it around. Anyways, sketches can get fairly complex or they can be fairly simple. So for example, this Crayola side sketch, this is driving all of the motor mounting and the drivetrain for this robot. So adjusting these numbers, let's make this 120 instead, adjusts everything else in this sketch. Because so generally, as you move down this feature menu, stuff gets less and less like general and more specific. So this is extremely specific or sorry, extremely general as in it's used by almost all of the like features in this part studio. So adjusting geometry here will change geometry all on a lot of these other features. So you can see changing that has moved my motors further apart. I'm just gonna Control Z that. Anyways, we're gonna go back over here. Whenever you're making a sketch, in order to exit the sketch menu and go back into your normal Part Studio menu, you have to hit check just to confirm all of your geometry changes. So if everybody hits check there, you should see you now have a new feature on your feature list called Sketch 1. We could rename this to be like Spacer Base. So in order to go from 2D to 3D geometry, the most common tool, and honestly probably like you could do most robot design without using any other tool in this list, it's going to be extrude. So Shift E or click on this button right here on your keyboard, sorry, on your screen, you're going to see this menu. So extrude has a bunch of kind of like sub tools in it. So the first thing you're going to see is you need to select faces or sketch regions to extrude. So anything highlighted in orange, if you click on it, it'll select it. So in this case, let's select that outer part of our spacer here. And now you can see we have the kind of like the ghost or like the preview of some 3D geometry. So there's a bunch of different end types in order to define like how long or what depth you want the extrude to go to. So blind just means you type in a dimension and it extrudes that far. You can do up, like if you have other parts in here, you can go like up to next and then select a face and it'll like automatically extrude it to be like flush with that face. In this case, let's just say the depth will be 30 mil. So, or I don't know, you can choose a number. You can also always drag this around to change it if you want instead of typing. And I believe, yeah, you can use your arrow keys to adjust it by 1 mil, and if you use shift, it'll adjust it by 10. You can also add, so this button here will flip the direction it's going. You can add a starting offset, so you can offset it from, by default, it always starts flush with where the sketch is, but let's say I wanted to offset it for whatever reason, I can add a starting offset, same thing, I can do blind, or I can select another entity in the sketch. Doesn't like that because it's not on the same plane, we need to make it, yeah. Anyways, you can also do symmetric, so symmetric on either side of the plane that it's on. You can add a second end position, so you could turn one extrude basically into two. Up here, you'll see there's a couple, so new basically means it's adding a new part to the feature. You can see in this preview here, we have a part 1, which is new. Add, yeah, add, this will just add to an existing part, which you have to select. So this merge scope basically means it will merge with a previous part that you already have. In this case, we can't do that because we don't have one. Remove will remove material from a pre-existing part. And intersect we won't really ever be using. Anyways, so if you hit check here, you should have something that looks like a spacer. So one thing I want to highlight in Part Studios that can be super duper powerful is this configuration panel here. So this is a little bit more advanced, but it lets you configure geometries so that they can be edited as you insert it into a different document. So what this lets you do is it allows you to create parts that can have like kind of adaptive geometry that you can change depending on the context you want to use them in. So in this case, this is a pretty generic spacer that if I want to make one that's say 45 mil, if I want to make one that's say like 45 millimeters long, I have to come back in here, edit it, and then create a new version and then insert it into my other document. What configurations will allow us to do is if we go here, we hit Configure Part Studio, you'll be left with this menu. configurations allow us to apply certain geometry to basically be a variable that you type in later. So if you go down here to this menu and you hit create configuration variable, we'll call this one length. I like to set the default to like not 1 mil because sometimes that can mess up your part. So in this case, we'll set it to say 10 mil. So the default, if left unchanged, will be a 10 mil long spacer. We hit check. Now you'll see this pops up here. Does everybody have that successfully? No. Okay. So you go click on this configuration panel button here, and then you go down, you click on the hamburger menu, and you hit configuration variable, and you should have a little menu that pops up like so. Type in your name, type in your default, and then hit check, and then you'll be left with this. Great success. 1 thumbs up, 2 thumbs up, 3. Okay. I'm gonna move ahead, and then if anybody has problems, we'll come back to that in a sec. So it says here no features are configured to this variable. So what we're gonna do is, if you double click on this extrude to edit it, you can right click on your depth measurement here and say set to length. So now you should see it shrinks down to that 10 mil size. You can see that we have 1 usage of this. If I close this here, let's see, we have a configuration panel up at the top now. So this configuration default is just something that it adds when you create a configuration. You can go, if you want to be a little more organized, you can go ahead and delete that. So now if I type in this, it automatically updates to whatever I set it to here. So this is super useful. And what this allows me to do is if I go in here and I go to an assembly, not that assembly, well, yeah, sure, this assembly. This is actually just, let's use it less. This document here, sure. So if I go here and I insert, I go other documents, home, and this is test. Oh, when did I put it in? Yeah, here. You'll see you'll have to create a version. So this is what I mentioned earlier with version control is you always have to create a version before you can see changes in other documents. But if I do that, I see this part 1 here. I can insert it, and now I can configure it inside this document, and it'll update. So now I can use this spacer as any length of spacer in any document that I so choose, and I can change it here instead of having to go in and change it in this document. So was everybody able, you don't have to try and insert it into something, but were you able to successfully create this? Amazing, we did a thing. All right. Okay, that's kind of like our basic 2D to 3D part workflow. I'm gonna highlight quickly some other tools here. We'll get into it more when we're doing the drivetrain, but other useful tools you'll see are gonna be fillet. So if you don't know what a fillet is, this basically just rounds something. It's useful, especially if you're gonna have parts that are getting machined. CNCs especially really hate 90-degree angles. So adding these can make your parts turn out a little nicer. It's mostly for aesthetic stuff, but sometimes you do need to use it to clean up like really sharp edges. Like same with 3D printers, they also really don't like 90-degree angles. So whenever possible, I like to use this tool to kind of smooth all of the corners around, and it really improves like a finished product coming off of a 3D printer or a CNC. Chamfer's the same thing, but it will make like a ramp basically. In terms of other tools that you can use here, there are like, most of these are like very specific and not super, like if you're designing like fairly simple parts or like 2D geometry, most of these aren't applicable. we won't be using them today, so I'm not going to go over a ton of them. The other one that is useful though is this plane tool here. So this allows you to create different planes on different surfaces, which can be useful if you want to make like a sketch on somewhere that isn't flat. You normally need to make a plane there first and then put a sketch on top of it. It can also be useful for using planes to define like spacing in your document, which we'll get into later when we do the drivetrain as well. So that's kind of your like basic Parts Studio controls. So we're going to go into assemblies. So assemblies are kind of like the other half of your OnShape document. So whereas Part Studios are mostly for like custom parts, so 2D to 3D geometry, making stuff, assemblies are for putting all of your Part Studios together. They're for putting off-the-shelf parts in, and this is where you kind of end up with a final finished product that looks like not just a bunch of parts kind of floating in space. So I'm going to delete these. Assembly, you'll notice your toolbar has changed again. Most of the time in assemblies, you're going to be doing one of two things. You're either going to be adding parts or you're going to be using mates to define how those parts are attached in relationship to each other. So one thing I see a lot of people doing with this is not defining like geometry with mates super well. So mates, every time you add a mate, it reduces your render time. It not reduces it. It has to render more stuff. So instead of using like 3 different planar mates to lock something in position, most of the time you're going to want to use one of these fastened ones. So let's assemble something in an assembly, and I'll show you a couple tools to make workflow and assemblies a little faster. So for OnShape assemblies are kind of what I find to be like the OnShape's weakest tool. Like in other CAD softwares, it's a lot easier to make stuff like this. OnShape has a couple drawbacks in assemblies, and there's no mirror tool. So if I make, say, one half of a drivetrain and I want to mirror it, it's extremely difficult to do it in an assembly. I basically have to redo it in a mirror version or derive it into a Part Studio and then mirror it and then put it back into the assembly. In this case, what we're going to do, we're going to go to this insert tool, and we'll start by inserting a piece of Go Build a U channel. So Home, Global Libraries, Go Build a, be under Structure, love clicking through hamburger menus, Channel, and you'll also notice too that this Part Studio has configurable U channel. So a lot of Go Build a parts where there's like, for example, like spacers, standoffs, U channel where there's a lot of like different lengths that it comes in, you can insert one of these and then wait for it to load. What? Okay, it's not there. Was. Do I have to configure it first? Yep.
It's on the top of one insert, but the bottom one. The one in the
Yeah.
not that one, but the one that.
Oh yeah, this, right. What? Bro.
Yeah, just click on it.
Zoomed out really far.
No, it. Okay, I'm just gonna use my other insert tool. Oh, okay. I don't. Bro. Yeah. Huh. Okay, we're just gonna do this then. Were you guys able to insert a thing successfully? No?
Yep.
Yes? Okay, did I? No. I did something to my render settings, I think. Okay.
It wouldn't be a real live demo if something didn't go wrong, right?
Yeah, so true. Did I think I did something funny to my render settings or something? Anyways, once you have that in, go ahead and also find a standoff from the parts library and insert that as well. I'll just there we go. Okay, so that's not what I wanted though. Let's go real. Structure channel. So, side view channel, sure. One of those, and then I'll also go grab a standoff. So we're gonna do a couple things. We're gonna use mates, and we're gonna use the replicate tool. The replicate tool, I can't speak. The replicate tool is super useful in it lets you create multiple instances of the same part super quickly, and it also is a little more efficient on your render settings, which is fairly important. I know I keep talking about that, but it is fairly important in assemblies when you get like a full robot in. You really want it to be super fast to render. There we go. Talking and clicking on stuff is hard at the same time. Okay. So now that I have these two parts in here, we're going to change the configuration of this. Let's say, I don't know, let's make it a little easier to see. So sure, 80 mil looks fine. And I'm going to change the configuration of this. So to change configuration of parts, right click on it, find the change configuration, or you can also right click on it over here. Or yeah, you can right click on it in either one and select that change configuration menu. So now that we have these two parts, you'll notice I can drag them around. They're not all attached to each other. So in order to attach parts together in an assembly, you're going to use mates. So M on your keyboard, or fastened mate up here. This is the most common one. Fastened just directly fixes two mate connectors together, and they're just locked in all orientations. So you need to select two parts. So you can select the center of the circle and the standoff there, and let's say the center of this circle here. Once you have those two, you'll see this preview here. Often you'll have to either flip this or rotate it to get it into the correct orientation that you want. Once you have it there, you hit the check mark. It assumes that you're mating more than one thing, so it automatically starts you with another instance. You can just close that. So now you'll notice we have two pieces and they're locked together. Was everybody able to mate whatever two pieces they put in the assembly together successfully? Yes, so if you hold shift at the same time, it should make it easier to lock to the center there. Yeah. So that isn't, especially like selecting the center of like a circle or selecting the right part can be kind of difficult with the like default snap settings. So you can always hold shift and it'll give you like more control over where exactly you want that mate connector. So for example, you see all of these white dots here. Those are all potential places that it wants to snap a mate connector to. It can be kind of difficult to select the one in the middle there, as you can see. So if I hold shift, it lets me select any of those easily. Yeah.
Do these standoffs typically have like simplified config? Those threads seem like they're gonna kill us eventually.
For the parts library does not. There is I have a yeah, the simplified parts library will have yes, simplified standoffs. These are also one that's fairly easy to make your own version of. Like, it's just an 8 mil flat to flat hexagon, and then you just extrude it. So that's one. Actually, you could even turn that configurable spacer fairly easily into a configurable one of these, so you don't have to render threads all the time. The other thing, so notice now, once you have a mate feature, you have this option down here. If you double click on it, you can edit it. A couple ones that are important, if you check this offset box, it lets you offset the mate. So sometimes you want to do this, like, most of the time you'll be offsetting it in Z, so like up and down. So now these are going to be mated together still. They're still locked together, but it's been offset by 5 mil from the surface of that. So occasionally you'll want to do this if you have like you have a tolerance that you know isn't going to be quite perfect, or you have like another part that you're waiting to add in. You can leave space for that. The other one, drag instances count too. Edit. You can also rotate it. So obviously the standoff rotation doesn't matter as much, but for something where you're mating like two gears together and you want to be able to see how the teeth mesh, you'll have to offset one of them. You can rotate. Normally you want to select rotate around the Z axis, or sometimes depending on which one you want to rotate around. So in this case, we could say rotate around Y by like 90 degrees, and it flips it there. All useful. So there's a couple other types of mates. So fastened is the only mate that defines all of the defines like a position in all axes. So if you're using like a planar mate or something, you'll be able to drag it around in one or more axes that it's not defined in. So sometimes that's useful. Sometimes you want to be able, like if you want to animate like say an arm, so on our, or for example, well, the slider mates are pretty rough sometimes, but for example, I have this animated so that I can drag our box tube around so I know our min and max extension. So I'm using, you see, slider mates here. There's a couple, we're not going to go over them. I don't love this system, but it is what it is. We're not going to go over those right now. If we have time at the end, I'll maybe go over like animated mates and stuff, but it's like a whole thing. And you don't really need them all the time. It can be useful. Just know that there's kind of like the two main ones you'll use are revolute, so that allows something to rotate, and slider, which allows for sliding. So some of the linear slides and like components with motion, so for example, otopods, when you insert them using the tool will come with certain rotation already defined. So for example, if you insert a Viper slide, I believe it comes with the like slides already animated. So that can be useful. So we're going to go over, let's say I wanted to add another standoff on like this hole here. Instead of having to go through the whole process of like insert tool, click on the standoff, insert the standoff, mate the standoff, and then we're done, we can use the replicate tool instead. So you'll see here, there's no hotkey for it, but it's right there. If you click on the replicate tool, you'll see this menu here. So instances, that just means you want to select a part to replicate. It will automatically select a mate to replicate as well. Most of the time, what you're going to want to do is hit this match individual edges. So this means you'll be able to, once you're in this blue box here, click individual edges to put a standoff on. And now I can just put standoffs wherever I want, except for those ones. And now you can see, super easy, we have 4 standoffs. The other great part about this is, let's say, oh, I wanted to change the length of this standoff. Change configuration. Let's go like 40 mil, 43 mil. It will update all of them instead of having to go and update each individual feature at once. So this is super useful as well. And this is that, and the fasten mate and the insert tool are probably the 3 most common things you're going to be using in an assembly. There is a couple more complicated things. So like you can apply like forces and stuff like that once you've defined like materials and all your stuff, and you can do force calculations. I Yep. Yep. Yeah. So yeah, I'll take a little break here and go around if anybody has any questions.
And yeah, again, guys, the bathrooms are kind of on the back here, so just around the corner here, and there's a couple options. Are you able to get replicate?
Okay. Does anybody have any questions, issues? Okay. Here we go. Yeah.
I managed to get the pieces in.
Yep.
Just one. I didn't know how to make the.
Okay. So
I got the main feature started, but I couldn't.
yeah, double click on the mate feature. Most likely, or yeah, that one. Most likely, yeah. So you have. Oh, what the heck? Okay. Oh, you made a mate connector, not a mate feature. So X, and then just right click and delete on it. Delete it. Yeah. So hit M on your keyboard. Yep. Okay. So now you have a fasten. So you need to select two mate connectors. So select like I don't know, the two part or no. Okay. Now you're. So you need to select them in here. So because if you select this part has like thousands of different mate connectors. Yeah.
Okay.
So that's one here, and let's say we'll mate it to the center of this. So you can see it's kind of, if you hold shift, then you can, so there we go. And you can't see that's clipping though, because it's going through the back. So if we go,
So you just selected a piece of the
Yeah,
inside of
yeah.
the rails, and then you said
selected,
shift,
yeah,
and then
shift. So it can be kind of finicky. It doesn't like auto snapping to certain things. So if you see like a bunch of white circles, those are all different spots where it can have a mate connector. If you hold shift, then you can pan around and it'll automatically select. So yeah, play around with that. You can play around with the replicate tool as well. And you'll notice it'll automatically like select another fasten mate for you. You can also mess around. There's a couple other different types of mates that you can try. Yeah. Okay.
Figure out like find where the
Replicate. Okay, so replicate is here, I think. Yeah. No, yeah, that one. Yeah. So click on that. Okay, so then you want to click. So first you want to click what you want to replicate. So say click on the standoff.
Yeah.
So now you have instance and a mate. So that's good. The match edges in face tool isn't great. That basically selects like all of the circles in, or like all of the mate connectors on one part. So I prefer this match individual edges here.
Okay.
And then you can select like I don't know, click somewhere. It's not gonna like that one because it's a curve, but like select like there. Yeah. There you go.
Okay.
Yeah.
Okay. And we're gonna have lunch sometime.
Hmm?
We're gonna have lunch.
Yes.
Also,
In
can I plug my computer?
yes. Yep.
clicked on the standoff.
Yes. So this is you need to. So right now you're selecting an instance. You need to. So click on this box here. So now you're selecting like individual edges to match. So now you can select other circles. It won't love the like for it to match. It needs to be the same geometry as as what this mate was defined with. So if this mate is on like a circular mate connector, it needs to be another circle basically. So like if you click on like this circle, like the big one, for example, it should add a standoff. Okay, never mind. It doesn't like that one. Try like I don't know. Yeah, so you see those are red. They aren't lit here. Can I just try clicking on something at all? Replicate. Since it's this guy. What? Sorry. That's strange. Oh, wait. Okay, that looks fine. Replicate this guy. Oh, you needed it to like. Wait. Oh, okay. Yeah. You made it to like. I actually don't know what's wrong with this. I think it's something to do with your mate feature. Like, so if I go and edit this.
Because I kind of just like
Yeah.
the center point.
There, boom, and then let's say replicate here. should, yeah, there we go.
There.
So yeah, sometimes it's a little picky with what the if this mate is defined kind of funny because it copies that mate onto the other ones. If that mate is like a little weird, it will get. So I think your issue was you had a circle selected that was part of one of the threads.
Yeah.
So that was why. Yep.
Piece of use question. Is
Yeah.
there any way to change the orbit mode to not be the serial pattern or to be more around the origin fusion or whatever?
Not really. So,
Yes, but I'm not. I haven't done it. So I think it'll be the menu underneath of your view cube. Like you want it to always orbit around the center, like kind of like how it.
Just it's kind of weird right now.
Yeah. I think it will be. It might be in your account settings. So, yeah. So if you go like your account or, yeah, and then go like preferences, if you can find something in there, I think this has like all of that like workplace like settings in it. Yeah. You guys are good? Yeah. 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 I know. Okay. Yeah.
When you're at a good spot, the next 15 minutes, let's start.
Yeah. I'll get you in a sec. Yes.
How do I use this configuration?
You want to make a part configurable, or you want to reconfigure a part?
I just want to make it configurable.
Okay, so you can't. Well, assembly configurations are hard. Do you want to like what exactly? Like, do you want to like reconfigure these parts to be longer? Yes. Okay. So clicking. It's not going to be in here. This is like. So this is these parts are already configurable. This is to make more parts configurable. So just left click in your window there. So right click on which one's the standoff? That one. Yeah. Right click on that. Right click. See change configuration. Click on that, and then type in the length or select one. Yeah. Yes. Okay. Oh wait, this is. Here, can I just? Okay, so this looks pretty good so far. So you have. What? Oh wow.
Maybe she wants to fascinate you.
Okay, can I? Okay, you have a lot of parts in here. So. Can I just delete the broken ones? Okay. So. Wait, what? Okay, we're just gonna we're gonna get rid of just clean this up real quick, and then we'll start like right again. Yeah. No. Yeah. Okay. Made features. So start fresh. So insert. All right. Yeah. Yeah. Use the search feature. Yeah. All right. I guess the Wi-Fi is kind of sad, or it seems to load slowly. Here.
She's faster than the Wi-Fi.
Yeah. Can I try? Oh yeah, there you go. Okay, so U channel. Let's just. Do you want to just do it with two pieces of U channel? Okay. Oh wait, now there's. This is so weird. Oh yeah, they inserted in the same spot. That's why. Okay, so they're like on top of each other. So now we have three, right? So we'll start by attaching, or do you want to change the configuration? Or let's just leave them as one by ones. So let's start by attaching two of them together. So yeah. You want to use fastened or M on your keyboard? Yeah. So now you need to select your two mate connectors. So select where you want to connect them. Maybe do select the circle. So the center of this top circle there. Yeah, that one will work. And then select like the center circle on this one. Yeah, perfect. Okay, so hit check mark. So now those two, if you drag them around, they're locked together, right? Or yeah. Okay, so hit escape because it started a second fasten for you. Escape. Yeah, there you go. Okay, so now we want to replicate that, right? So find your replicate tool. Yep. So instances. So select one of these parts that you want to replicate. Yep. So now you need to change this from match edges in face to match individual edges. Yep. Now select, say, I don't know, like a circle on this part, and we should get another U channel. That's an arc, not a circle. It's like weird, but yeah. So delete the red instance, yeah, and then hit check mark. And now, if you drag them apart, you should have two of the same. There you go. Make sense? Yeah. So now, if you want to like insert some other parts and like play around with like putting them together, that's basically. Okay, who else had questions? You're good now? Okay. Yeah. You want to mate them together? Okay, so hit M on your keyboard or select the fastened mate. Yeah, so now select, say, like, I don't know, wherever you want to put the standoff. Yeah, and then, yeah. There you go. Nice. Okay. More questions. Yep.
Yeah. So
Replicate.
I can access them match to edges.
Match individual edges
Yeah.
in face. Yeah. So yeah, click one more down. Click on it. Yep. Yep. And then now select circles. Choose a circle. Oh, trackpads are hard. Do you want my mouse? Are you sure? I can. You're gonna have to oh, this might be another instance of your mate. If your mate is funny, like so, because it What did you mate it to originally?
I think I made it. Oh, I might have made it to this.
If your original mate connectors are like kind of weird, sometimes it messes. Like so, you see how this is mated to like a curve instead of a circle? It won't like if you try selecting another curve instead.
Oh, I guess it.
It copies the original mate. So if the original mate is kind of weird, then the replicate is also messed up. Yeah. Yep.
How do I like replicate?
Replicate. Okay, so click the replicate tool. I think it's that one.
Like this one?
One to the left. Yeah. Okay, so select let's say the screw. So click on the screw. Yep. Click on this and change it to match individual edges. So click and then yep, that one. And now click on some circles. Boom. Nice. You're good? Or no, something's broken there. Okay, so your mate I think doesn't have enough mate connectors to find. So double click on this fastened here. Oh, you selected two mate connectors on the same part. Okay, so hit X on both of those. Or like, yeah, there you go. That should work now. So hit and then hit check mark. Okay, so now you have two pieces attached, and then you should be able to replicate them. Yeah, that's fine. Okay, is everybody else good? No, okay, we have questions over there. Oh, dark mode warrior, and with the trackpad. Holy. Okay. Yes.
How do I like?
Connect them.
Yeah.
M or yeah, this one right there, and then so let's select. I don't know, where do you want to put the standoff? Click somewhere. Yeah. No, you gotta yeah. Good. Perfect. Oh wait, nope. This. Right. Okay. It's kind of finicky on like what it selects. So because it's really specific about like where it wants to put it. Oh, this is all. I bet the Twitch people love listening to me help people out. So because it's all, because there's like a different like a, it's very specific. So like if you just like click generally, it often will just highlight the entire part and then it's sad. So zoom in a little bit. Let's say like the middle of the big circle. It's probably easy. So you see how it's not highlighting anything? That means there's no mate connector there. So you want to highlight like an edge. Yeah, there. Okay, so now we have one. Now where's the stand? Zoom out and find the standoff again. Hold shift. And then that should let you select like, or yeah, let go of shift. Oops. Nope. Bruh. Okay, zoom in. Where you want to select like it takes some time to get used to. So you want to select like the front face of it probably, right? So zoom. I thought I went over that. Maybe I was speaking too fast. Okay, zoom in. Shift. Oh wait, no, never mind. So when you see a white dot in the very center of the thing, so no, highlight the face. Yeah, see, there. Yeah, okay, close enough. You have something. What we actually want to do though Oh no, I got rid of it. Right. Here, can I just use the mouse real quick? Okay, so you gotta highlight on the face, and then when you see that white dot in the middle, hold shift, and then you can get middle of that, and then let's say like I don't know, this here. Flip primary so it's on the outside. Done. Now they're connected. Kind of makes sense. I think Jack knows how to do it, so you could also ask him instead of me if he can help. So does that kind of make sense? Okay. And then if you want to try replicating or like inserting more parts and like doing anything at all. Okay, do we have any more questions? Okay. Zoom. Did you figure out the like pan around origin thing? I'm gonna take that as a yes. All right. Oh, this might be a. Did you hit like control? Yeah, you just zoomed out. You might have if you hold. I think on Windows, if you hold control and then scroll. Oh, maybe it's not that. There is a hotkey with like some key and scroll wheel will automatically zoom you in and out. So that was just like a Windows thing. But yeah, are you good now? Okay. Yeah, no problem. Yeah, nice. Okay, did we successfully do a thing? Everybody has something in an assembly? Are we taking a break for lunch now, Dad? Is that the plan? Good stopping point? Okay. Yeah. Speaker notes.
Hello, Adrian.
Yeah.
Let's say that is a new channel that you selected,
Yeah.
and because this is solid, right?
Yeah.
And this is not the actual length you need.
Mhm.
And you know the change configuration right now have preset lengths.
Yes.
How do you bring it to the size that you want? You can,
Like, oh, if you want like half a U channel?
yeah, let's say the standard length is 26, because if you go to change configuration, you do that drop down
Yeah.
and you have preset lengths. Let's say you want to take 1 millimeter off or 2 millimeter off, shorter than what you have there.
What you'd have to do, there's no way to do that in an assembly, so you'd have to derive it into a part studio and then extrude, remove, and just like remove 2 mils off. So in part studios, typically you cannot import like you can't just insert 3D geometry like willy-nilly in the part studio. Part studios are for building geometry, not like assembling geometry. So in order to get a 3D geometry in like a pre-made 3D geometry into a part studio that you want to modify, you need to use the derived tool here. So you'll have to like import it into the thing and then yeah. Okay. So if everybody kind of understands how to like it's basically like Lego on your computer, I guess, with Go Build a Parts or whatever. If everybody kind of understands how to do that, that's a rough overview of part studios and assemblies, which are your two main components. For a lot of teams, you should be able to build a majority of your robot in this assembly menu just by mating stuff together using pre-made parts. Like, and this is a really good way to find like if certain parts will fit together properly, and kind of see how that will work. It's also a decent way. So let's say this is another one that I saw people struggle with is, let's say they have a strafer chassis and they know that, oh, we built it with the instructions, but they don't have a CAD model for it and they want to make like a plate that mounts to it. Let's insert I'm going to use the other one because it's nicer. Let's insert a strafer chassis here. You guys don't have to follow along with this necessarily. I'm just going to go through it real quick. And then we'll take a break for lunch. Oh, nobody updated this. Wow. Okay, so I'm going to insert the old version of the strafer chassis. I don't know why that's there. So now I have this, but let's say I want to make like a plate that mounts to it. I can't just like start sketching in my assembly menu, right? This tool over here, Create Part Studio in Context, this is super duper useful for making geometry in context to something that you already have. So as you can see here, I'm now in a Part Studio menu with kind of this ghost or like transparent overlay of the Strifer chassis. So what I can do here is using this, I can create a sketch, and using the Use tool, yes, I can say select these holes that I want to use as mounting for the plate in this Part Studio. And now I hit this X and I'm left with a sketch that is relative to this part in this assembly here. So this is super useful for like, let's say I already have like an elevator geometry or like I've built like a lift and I want to put an intake on it. And instead of going in here and using the measuring tool and like measuring like, oh, this hole is like so far away from this and then like manually entering that into my sketch, I can just derive this here and then, or sorry, not derive, create a Part Studio in Context and then use the Use tool, should call it something else, the Project tool, I guess. I don't know what else it's called. Basically, you can take geometry from that assembly and turn it into a sketch or something to be extruded later. So that's useful for like workflow between like, oh, I have, or like I already have this thing that we've made. I want to like put parts onto it, or it's useful for like, oh, our final robot is done. I want to add like some like cover shroud pieces or something, and all of the geometry you don't need. Like, here, let me find an example of this. I think I have one somewhere. For example, like, in this robot, I have a Part Studio that has all of my plates that are in the same position as they would be on the drivetrain. However, that Part Studio is missing some things like this U-channel, these motors where this battery is. So if I wanted to make like a cover that goes on top of this battery, I wouldn't be able to do it in this base geometry sketch because I don't know where any of that U-channel and stuff is relative in here, right? So I can create a Part Studio in Context and then use that to make my like shroud cover or whatever. I think that's a pretty good spot. Yeah, that's probably a pretty good spot to leave it to take a break for lunch. So, what time is it? We're doing actual stuff soon. Yeah, yeah, James Bond billion. If anybody has questions, I'll send you first, and then I'll keep talking. Okay, is everybody back more or less? I think we have most of the people back. Okay, I'm gonna briefly go over kind of competitive drivetrain, like what? Oh yeah, I guess this is Sheldon. Everybody say hi, Sheldon. Oh, that, yeah. Sheldon's from Forge. He was their CAD lead or one of their CAD leads. Yeah, I guess you want to introduce yourself, or no?
I'm Sheldon.
Yeah, he's Sheldon.
So I'm a CAD lead for Forge, and I'll be helping you guys out with any questions you have regarding CAD today.
Yeah. So he's like a second set of helping hands for CAD questions. He's not super familiar with like specific FTC stuff, but he's definitely able to help you out with like my OnShape thing is broken. So yeah. I'm gonna briefly go over drivetrains, so competitive drivetrains for FTC, what most teams run, and what we're building today, and then we're gonna get into a little bit on linear slides and rigging, just because I see a lot of teams having issues with those, and then we're gonna move into actually building a drivetrain by hand. So first of all, what are kind of the four main drivetrains in FTC? We have mecchanum, X-Drive, Swerve, and Tank. Tank is cool. Swerve is hard. X-Drive is good. mecchanum is good. That's basically my ratings. We're going to go in real quick here. So mecchanum, the two types of mecchanum drivetrains you see are parallel plate, which is this one here. This is really common for competitive teams to run. So it gives you lots of like customization, lots of modularity. It keeps the packaging super, super small. So it keeps your drivetrain really out of the way and lets you build lots of complicated mechanisms on top of it. These are a little more expensive because they do involve getting plates cut by either on a CNC or a water jet or by some sponsor. It's super customizable. That's what we're going to be building today. I think it's probably the best option for a drivetrain in FTC for like mid-range to competitive teams. Go build a Strafer chassis. I love these things. They're great. They're super good for beginner teams. It's like you like assemble it and you're good to go. They can still be very, very competitive. This year, the #1 OPR in the world for quite some time was running on a Strafer chassis with plates built on top of it. So I don't know if any of you are familiar with I Forgot from Washington, but their bot that won Washington State Championships was Go Build a Strafer kit with like basically a big turret arm on top of it. They do have a couple drawbacks. They're pretty large and they're a little more difficult to customize. X-Drive, I see Weber traditionally has run this like every year. X-Drives are cool. They have a couple drawbacks compared to mecchanum. They don't have as much traction, so they do run into issues, especially in games like this year where pushing does happen quite a bit. They kind of tend to get shoved around the field pretty easily. They're super cheap though. They're pretty easy to build, and they have good library programming support, so it's super easy to just like kind of throw them. Yeah.
How does the speed up change based on like mecchanum and X-Drive? Because I know that X-Drive moves like 1.4 times faster in forward, like linear movement. What about mecchanum?
There's a paper on this somewhere. If you look up, it has like graphs on like directions. Generally speaking, mecchanum and X-Drive are going to be fastest straight forward and straight sideways, and they'll get slower on the like northwest, northeast directions. I think X-Drive is more of like a round circle, like it's more consistent all the way around the circle, but it has less traction, so it tends to slip out more. And in reality, I think you end up getting less power out of an X-Drive than you would out of a mecchanum system, just because there's less traction. The mecchanum wheels, like the Go Build a mecchanum wheels, do have issues with like side like strafing. You get significantly less power than you mathematically should, because the little yellow bits underneath of the rollers actually dig into the foam tiles and slow you down. Yeah.
Explain how, like, you have 4 drive motors. What's your maximum?
Well, yeah. So on both X-Drive, wait, maybe X-Drive gets slightly more than 2. I think. No. Okay. Both mecchanum and X-Drive at max, you're only getting 2 like drive motors worth of power forward because of the way the vectors cancel out, right? Like if you have half your motion on a mecchanum wheel's always going sideways. So when you have 4 wheels, half of the drivetrain power is actually going into canceling out the sideways vectors on the wheels to just give you forward motion or just give you sideways motion, which is why they're less efficient than something like a tank drive or like a swerve, but they are super easy to build and there's lots of library support for them, so generally that's what teams run. X-Drive, there is an interesting paper on holonomic motion using omni wheels. Any number of wheels above 3 should be able to give you omnidirectional motion, and the more wheels you have above 3, the more redundancy you have. So you should be able to, like say with 5 wheel or whatever, you only need 4 of your wheels to function, and one of them is basically there giving like redundant extra support. 5 wheel, a couple teams have run 5 wheel X-Drive in the past, especially in power play, it was fairly common. But there's little library support and it's kind of hard to build. Kiwi is super great if you're limited on parts. So for school teams that have like only 1 control hub, for example, Kiwi is a great way to get holonomic motion without compromising sacrificing too many motors for your drivetrain. Swerve, I'm going over these pretty quick, I know, but this isn't super important. Swerve is hard for FTC. You basically have to do it fully customizable. It's very difficult to get functioning properly. There's no like kits like in FRC, but if you can do it, I think it can work pretty effectively. There's 2 main types. There's coaxial swerve, so you have typically a servo driving rotation and then a drive motor driving actual power of the wheel. It's going to be literally twice as efficient as a mecchanum drive, so you're going to be able to push other teams around fairly easily. You're going to be faster, but it does come with a lot of extra points of failure, so drawbacks. Differential, similar idea, except for you have 2 motors, and the difference in power between them causes the module to rotate. So if they're running at the same power, it just drives. But if one of them is running faster or slower, then it will add some rotation as well as driving. If you want to talk to me afterwards about differentials, I can show you a couple different designs. They're fairly complicated, but they can lead to some fun looking robots. Finally, tank. It's only good if the game is very strange, but it can be very effective if the game involves like ramps or like if any of you were around for Freight Frenzy, Actually, I would have argued that a tank drive was maybe better than mecchanum drive in Freight Frenzy because of the amount of pushing you had to do to fight over the shared shipping hub. Sometimes it's worth the drawbacks of not being able to strafe to actually run tank. Okay, now we're done speedrunning drivetrains. I'm going to talk about lifts and linear slides. This is something that a lot of FTC teams I find struggle with getting stringing right, choosing the right slides, rigging them correctly. There's kind of there's three main slides that people use in FTC. I would argue that the most common, especially for competitive teams, are Mizumis. So this is a type of drawer slide that has been used by FTC teams for like the past 5 years or so. They're super duper durable. Like there's videos of teams like spinning around with their arm at like 45 inch extension and like smashing it into a wall, and the slides still retract. They're super duper light. They're super fast. I know a lot of teams struggle with like getting inserts and stuff for them. If you look on our website, there's a link for an insert for rigging Mizumi slides. I'd recommend, there's a bunch of resources that online for like how to rig them, how to use them. They're probably your best option for doing linear slides if you want to go something custom. BWT Link is also similar. They're fairly compact, similar to Mizumi. They're designed for FTC. They come with inserts, but they have some hardware issues. The end stops break on them semi-frequently, which causes all of the bearings to fall out of your slide, which is obviously not good. Viper slides from GoBuilda, also a good option, super durable. They're really heavy though, so I would try and avoid them if you're doing like a lot of linear extension or a lot of, especially horizontal extension. They tend to have enough sag in them that your intake or whatever will end up like touching the ground at max extension. Box tube, if you want to talk to me about this, obviously we've built a box tube elevator before. I'm happy to offer lots of design tips on that if you want to pursue that with your team. It does require a decent amount of CAD and a non-zero amount of like custom fabrication, but it can be a good option, especially if you want to keep your robot nice and compact. Stringing. This is the one that I see everybody struggling with. Look at the diagrams. They're so beautiful, right? Yeah. Okay. So for stringing, there's kind of two main things you want to keep in mind. Your string needs to stay on your pulleys. So almost all stringing systems need to have some kind of tensioning method. So if your string doesn't have tension on it, it's going to hop off of the pulleys. It's going to hop off of your drive pulley. You're going to have like, if the string skips, then something's going wrong on your elevator, right? So you either need to have, like, regardless of if you have like pulley guards or like something like that, the string losing tension still causes issue, right? Like if your string loses tension, the slide will kind of like fall really fast and then catch itself, or like extend slowly and then kind of catch up as the string comes in. You want your string to be nice and taut as it goes through the system. So there's kind of two ways that people add tension to the system. The most common one is on your retraction string, which I do highly recommend doing, even if your linear slides are only going straight up and down. I would recommend adding a retraction string regardless, just in case they get caught. If you want to like hang with them, something like that, or if you're doing counter springing, which is something we could talk about after. But most common system is to add a spring on your retraction string. So between your final mounting point and the bottom of your retraction string, you'll have a spring to add tension to the system. You'll tie your string off a little shorter, and then stretch the spring onto the mounting point. This adds tension to your system. It prevents the string from hopping off. So like if you can see here on our robot, the string has like, I can pluck it like a guitar string, right? So keeping that tension is really important for having a consistent lift. The other option that a lot of teams use is using like a guitar pick or like a guitar style, like wind it to add tension to the string. This is a little easier to like, you don't have to like retie anything to like retension your strings if they stretch. This is also a super good option for teams. Slot tensioners. So this is something that we use this year. It's effectively like a T-slot tensioner where you stretch the string into the T-slot and use a string that has a little bit of stretch in it to add tension to your system. This one's a little less, I would say it's a little less effective than a spring or like a guitar style one, but it can work as well. In terms of rigging, I see a lot of teams either tend to rig most teams tend to rig continuous, which is a pretty good option. honestly, I'd probably recommend it over cascading, but cascading is necessary sometimes if you like don't have access to a fast spinning motor. So if you want your slides to go fast, you need to sacrifice torque. So obviously your slides need to be light, or you need to run them with multiple motors. So one thing that I see a lot of teams in Alberta doing is they run their slides with 1 or 2 motors. Almost all of the competitive teams at Worlds had at least 2 motors on them, if not 3 on their elevator. So running more, like, in the grand scheme of things, when you're cycling on a field, right, if you look at a lot of robots this year, they're waiting for their elevator to extend while they're already in front of the basket. So that means that they're losing cycle time because their elevator cannot extend like it needs to be able to get to max height while you're driving over to the scoring objective. So in order to maximize your cycle time. So improving lift speed is really, really important in getting your cycle time much faster, especially in something like auto where the preloads are like right in front of you and you can just, it's almost entirely elevator motion and little drivetrain motion. So for running like faster slides, you need to either rig continuous with a higher RPM. Continuous is easier to rig because your pulleys are the same size, right? Your retraction string and your extension string are the exact same pulley diameter. For cascading, your retraction string has to be proportional to the number of stages you have. So for every additional stage that moves, you have to, it basically becomes a fraction, right? So your ratio is like number of moving stages over, or like 1 over number of moving stages, yeah?
Can you just explain like the difference between cascading and continuous rigging?
Yeah.
Just like explain the diagram.
Okay, so for cascading, what you do is you have, as you can see on the diagram, you have 1 retraction string which just pulls on any one of the slides to pull it in. For extension, you have multiple sets of string, so 1 from your pulley to the top of a stage and then to the bottom of the next stage, and then you keep doing that. So top of a stage to the bottom of the next stage. So the effect that this gets is, here I can demonstrate on this. When you pull in 1 length of this string, it moves all of the stages by that amount. So what this means is you only ever have to pull in, say this is a 14-inch stage, you only have to pull in 14 inches of string to extend the lift to its full height. So it ends up being much faster, at the drawback of you have to have, each string has to have its own tensioning system, right? Because they're not connected. So for continuous, you only need to add tension to like 2 strings, right? The retraction and the extension string, and they're all the same. Whereas with cascading, you have to add tension to each separate stage of stringing. So that can get, like, we had issues with our second stage strings would hop off their pulleys, and then that would derig our final stage of slides. Another drawback of cascading is because all of the slides are linked, if 1 slide stops working, your entire elevator will be stuck in a position. Whereas with continuous, if one stage stops working, the rest of them are still able to function. So you can still perform if like one of your slides breaks or whatever. Yeah, that was probably a bad but brief overview of linear slides. We're gonna go into drivetrains now. Yay. So we're gonna make a drivetrain. Everybody, let us open up a new OnShape tab. We're gonna make a new document. Boom. Let's call it drivetrain or something. Yeah. Okay, if at any point you're struggling with something, you mess something up, put your hand up, Sheldon will come over and try and help you out. If Sheldon has no idea, he can come and ask me, and if we both have no idea, then we're gonna hit Control-Z until we're back at some point where we know what's going on. I'm just gonna say it right now. It frequently happens where you end up over-defining your sketch. So what that means is you'll like dimension something twice and they're conflicting dimensions. In that case, your sketch will turn red. Most case, it's best to just hit Control-Z until your sketch is no longer red and then start adding dimensions again. Sometimes you'll have to find like, oh, you accidentally like made something horizontal to something you didn't want it to be horizontal to, and you have to go find that and delete it. But most of the time, if your sketch turns red, that means you've over-defined something. So given something too many dimensions, you're gonna need to like take one of them away. Okay, so I'm gonna introduce, we're gonna start by making what I like to call a master sketch. So master sketches are something that's gonna define like some very basic but very important geometry for the like basically everything on your drivetrain or everything on the part you're making. So in this case, we're gonna start by creating a sketch on our top plane here. This sketch is going to contain our drivetrain motors as seen from above, as well as our side plates as seen from above. So we're going to start just with a simple line. So L on your keyboard, or you can click up here. We're going to draw a line that is parallel. Well, we'll draw one line like this. We're going to dimension it. So D on your keyboard and click on the line. Typically, for parallel plate drivetrains, they're anywhere between 12 and 18 inches long on the side plates. I think a good starting point is somewhere in the middle. I like 14 or 15-inch drivetrains, so we're going to type 14-inch in here. Yeah, we already did that. Yeah. So we can type it. You can type in 14 and then inch. I know that most of the time you're going to be working in millimeters, but for stuff like this where it's like relative to the sizing box, which is given to us in inches, I just like to do that for kind of simplicity's sake. Now you have one line here. We're going to make a second one. We're going to make it so equals tool or E on your keyboard, and you can select the two lines. Oops. I can't click on stuff. Okay, there we go. So now they should be the same length. You can see they're still not fully constrained, so we're going to Shift S, put a point on the midpoint of this. I guess there's an easier way to do this. Never mind. Well, okay, there's two ways to do this. So we want to make the center of this like centered on our relative to our origin. So you could either make the two ends of this symmetric on the front plane line, or you could Shift S and then Shift M. So make a point and then make it the midpoint of this line, and then make that horizontal to here. Okay, so once everybody has two lines, one of them horizontal to the midpoint, we're going to make the top of this horizontal to that. So now you should have two lines that you can't drag up and down. You can just drag side to side. Next step, we're going to define the width of our plate. So most drivetrain plates are 1/8 of an inch, or 3.175 mils. That's not a 1. So this will just kind of define how wide we want the plates to be. Yeah. Okay, does everybody here? No. Okay, I'm gonna go around. I'll be right back. 1 second. Okay, okay. Are your default settings in inches? They might be. I think, well, this is 14, so I think, unless that's 14 mils, which I'm pretty sure it's, can you double click on it? Or yeah, if you measure, that'll, or wait, escape, double click on this dimension here. No, the black text box. Maybe you just have display things, it's fine. Okay, so 14-inch, zoom in, I think you have two lines there. Oh wait, no you don't. Okay, so now we're gonna dimension the distance between these two. So hit D and then click on this one, and then click on the next one. Okay, so we want those to be 3.175 of a mil. So mm. Yeah. Okay. Nice. So the other thing you're gonna run into. So try and drag them around. You'll notice you're able to drag them up and down horizontally, which we don't want. So we're gonna do two things. We're gonna zoom in. We're gonna pan down to the bottom. Can you pan? Yeah, horizontal, so H, and make the ends of the two lines horizontal to each other. Yep. Okay, so now we also want them to be centered. So lock to the top again. And we're gonna do, so there's two ways to do this. So I did it by creating a point in the middle of the line and then making that point horizontal with the origin. The other way you can do is go to the symmetrical tool. Oh, your toolbar is really small. Here, so click on this hamburger menu up there. Down one, that arrow, yep. And then you're gonna hit symmetric. And then click the top here. Yeah. So you're gonna. This is like this line, and this point. So now, if we've done this correctly, when you click on this line and try and drag it up and down, it shouldn't move. So now we can only go side to side. So you're good. Also, go to the hamburger menu and change your workspace units. Change it to millimeters. That way you won't have to type MMs in every time I say. Or
Right now you're making points.
oh, that's why. That's why you couldn't drag.
Oh.
Because you were on the point tool. Yeah. Okay, so yeah. Yeah. Like between the plates. Yes. Yeah. Okay, so dimension your distance between plates to be 3.175.
How do you do that?
So you hit D or go lock to the top plane. Hit D for dimension, and then click on the two. Yeah, so 1, 2, 3.1 or type. Yeah, click again, and then type in 3.175. Yep. Enter. Yeah. Your default should be mils. So yeah, and then I think what we need to do. So this should. Yeah, that looks good. So you notice this one. Oh, we still have the dimension tool defined. Oops. This one. This one can be dragged up and down still. So what we're gonna do horizontal and then those two. Now we're good. Okay, and yeah, make sure like what you'll have to hit escape to like deselect a tool so you can drag stuff around. But now you should be okay. All right. Is everybody else good? One more? Okay. I'm gonna go more slowly next time. Wah. Oh, okay, I'm going. If you want to go, okay, so select all of those, copy paste them, and then make the distance in between. So you should have two of those. Make it 56 mils in between the inside of each plate.
56 mils in between both of them.
Yeah, and then yeah, that's I guess. And then make sure that after you've control C them, make sure you have make sure it's all like properly defined again. So like try dragging stuff and then yeah.
This is a rectangle right now. Is that all right?
Yes, a rectangle would work as well. I like 2 lines because it's easier to think about. But yeah.
Okay. So say your dimension. Hit D for dimension. Then click on the two
Like the,
parallel
yeah.
lines. Yep. And then the other one. Now drag it out just a little bit to the
Yeah.
right, I'd say.
Just so you can see the text, yeah.
Click. And then 3.175 millimeters.
So what it's wanting to do is add more dimension. You're in like
Now, Yep. Now you want to define it with relative to the origin, so zoom in. Yeah. Draw a point on your leftmost line.
Yeah, so Shift S for point, or you can click the point tool.
Just click the point tool. I don't use hotkeys, man. Yeah. Just on your, yeah. Good.
Oh, yeah, I'm gonna go.
Now, escape.
Yeah.
Click on the point.
Wow. Okay, I need to go. Yes. Perfect. And they're 56 mils apart?
Yep.
Nice. Okay.
How do you copy and paste lines?
Select them and then hit Control C. I'll go over this in a sec with everybody. I'm gonna go a little more slowly, I think, and hopefully that'll help. Dad, does anybody on the stream have questions? Okay. Oh. Okay. If everybody's here, I think we're good. Oh, okay. One of them is probably Sheldon. One of them's constrained like on the x-axis somehow. Like he probably when he made a line, he probably had it like accidentally horizontal to something or.
I think that's just a graphics convention.
Bruh. Good or. Yeah. Okay.
Oh yeah, you're good.
Yeah.
This line goes up and down, but then this one only goes sideways.
Yeah. So use horizontal or H on your keyboard, and so click the top point on that one and the top point on the other line, and now you should be good.
Click away. Just click away. Yeah. Now, hit escape.
Yeah.
Now click the dimension that you just drew, and then delete that. Just the one of them. Because you want to set them. Yeah. Click that, and then just hit delete. Okay. Click your two lines, and then set them to. Not to point.
Okay, this is gonna be entertaining, I guess. Well, maybe we can get one plate done. Let's see.
And then drag it. Just click somewhere, and then Now specify millimeter afterwards because you're operating in centimeters.
Do you know if you care at this point where it is?
No, we're gonna define it. We'll define that after. Okay, so once everybody has this, we're gonna select it. Yeah, so once you have it entirely selected, Control C, Control V. Second one. Now we should have two. Once you have two of the same, we're gonna hit H on your keyboard or select the horizontal tool up here. Select this point and this point. Or you can do it with the end, like the ends, it doesn't matter, any of the points, just as long as they're the same on both sides, and then use the top ones then. Once you have those two, you shouldn't be able to drag this one up, dimension, or D on your keyboard, or select this guy up here. Make sure you select the inside lines, and we're gonna make that 56 mil apart, which happens to be the length of a GoBuilda 7-hole square beam. That was definitely what I typed into that search engine. Close enough. This guy. Oh. Nope, 56 is the 8-hole. One of them's 56. Yeah, 7-hole. There we go. I clicked on the wrong one. I do remember what I'm doing, I think. Okay, so now we have these. So this is the this is the basis of what our side plates are going to look like from the top. We're going to define how wide we want our drivetrain to be. So dimension or D on your keyboard or this guy up here. Outside line to here or to the origin. generally, if we're going, generally drivetrains tend to be square. So if we went 14 inches up, we're gonna go 14 inches out. But because this is only half of it, we're gonna type 7-inch in. Yeah.
Where do you define relationships in OnShape?
Like
if I
relative?
wanted this to be half of the length of that.
I know you can do like math in these, so you can put like slash.
Then you're able to type in math operations in you. I just have to make sure it's with you're all good with units and whatnot.
Yeah, like you have to type like I can type like yeah like oh, not that. What did I do? Like I can type 14-inch divided by 2 int and then
No, just two, right? That cancels out the units.
But what? Sorry.
yeah.
I
Oh,
don't
like
look at
relative
that.
to relative to something else. I actually don't know. I think you need to make it a
Also, like
variable.
Dimension, like cross-dimension things.
Yeah.
In order to do that, you can make use of a variable table. That's why
Yeah.
with our elevator. By making use of a variable table, you're able to set like larger variables. OnShape isn't great with this. It's not
Yeah.
like SolidWorks where you can say equals another dimension.
Yeah.
Which is quite annoying.
Well, you can use the equals tool, but it doesn't work exactly the same yet.
You have to set your equals to variables.
Never mind me.
Yeah.
Adrian, the questions here, they're asking on the stream if you can go over again how you made those vertical lines and just line them up.
Okay, so line tool or L on your keyboard. One like this. Second line like that. Dimension one of them or D on your keyboard. 14-inch. Nope, that's 14 inches. Nope, not 14 mils. There we go. Equals or E on your keyboard, like so. And then horizontal or H on your keyboard, make the 2 horizontal. Then you have your 2 lines. Okay, does everybody have something that looks kind of like this? Okay, there's one in the back. Wow. Yep. Yeah, you've just wait. Okay, so you've made a line here instead of dimensioning it. So delete that. Hit D on your keyboard. Dimension like that, and then type in 56.
Dimension from
Point
origin to outer.
origin to outer was 7 inches.
7 inches. Type 7 in.
54 or 56. Sorry, 56 mil. Yeah. Enter. You don't need to type mils in. Your default should be mils. Yeah. And then dimension again. So you still have the tool selected. So click here and we click there, and then type in 7 inches. Yep.
Could you able to like copy this without using the copy function? Like once you have the two.
Yeah, you can just Control C, Control V.
Oh.
Yeah.
Okay. All right. I thought it was a different word.
No. This guy's locked in. Edgar, I think to answer your question, you have to use, if you go over here, you should be able to make variables, and then you have to like define it as a variable, which isn't great.
Construction geometry for the win.
Yeah. Oh yeah, construction. Yeah. Yeah. Oh yeah, that's true. Okay, is everybody approximately here? Okay, we're gonna go. I guess yeah. Let's do that. We're gonna define. We're gonna make another line. This line is gonna be our motor mounting plate. So where we mount our drivetrain motors. So we're gonna draw a line on the side here. Same deal, make a point in the center of the line. Make it horizontal with the origin or one of these point or plates here. We're gonna dimension it to be like 68. Yeah. Dimension it to be 68 mils. And then make it dimension again to make it 32 mils away from here. Should be correct. Yeah. Okay, so once we have this, we can select all of it. Or wait, no, we gotta hit the mirror tool in the middle of your toolbar here. Select, I guess, yeah, we can make, you can either select this line here of the plane, or you can make, if it makes you feel better, you can make a line in the middle. And then mirror, select this line here as the mirror line, and then select everything over here, and now we'll have two, one on either side. Yeah. Did you not know there was box select?
I mean, like, no, I mean, like, mirroring things by, like, selecting them individually.
That's criminal.
That's painful. Yep.
So like, how do you like line up the plates?
Parting gift.
Okay, is everybody approximately here? How did I mirror it? There's a mirror tool in the middle of your toolbar. If your UI is really tiny, it might be hidden underneath a hamburger menu.
So your sketch is red. What this means is we hit Control Z until it's
Yeah.
So Control Z.
Yeah. Okay, two things are a little off here. Yeah, so you're missing your dimension between plates was that intentional that you made it 100? Okay, 56 mils should be what that should be instead. So you're right now you have the mirror tool selected, so hit escape and then double click on the 100. Make it 56. Okay, and then you're missing your motor mounting line. So we're gonna make a line. So L on your keyboard. Draw a line. And somewhere, yeah, click and then down. Yeah. Dimension it to be 68 mils. So just type 68 in. And you, yeah, that works too. Click again. And then 68. Yeah. And then Shift S in the middle of the line. No, hit Shift S for, so make a point. Shift S is make a point, and then click in the middle of the line. Yep. And then hit H for horizontal. And then click on the point and click on this guy. Yep. And then dimension, or D, this between this line. Yeah, that works too. And the outer line on that plate. Yep. And then 32. Nice. You're also missing the motor. Oh, no, you have it. Yeah, perfect.
Just missing a line.
Yeah.
I managed to mirror it, but I'm missing this line in the middle.
Okay, so L,
Yep.
draw a line. Yeah, make it 68, so just type 68 into your keyboard. So as soon as you make something, you can type the dimension and that'll define it. That's 6.8. Oh, you have centimeters as a default. That hurts me. It's okay. Shift S in the middle of the line for a midpoint, or on this one. You already have on the line you just made. There, yeah. And then horizontal. So H on your keyboard, or click there and then click on the origin, or yeah, that one too, and then up here. Yep. And then dimension it to be 32 mils from the side of the inner plate. Yep. Wow. Okay. How do you mirror? Oh, you have a tiny UI, I think. This one. Mirror. Here. And then shift, like select everything. Oh, you have a mouse. Okay. Wait, how did you mirror it?
I already mirrored it. I accidentally deleted the line.
Oh, okay. You could just Control Z until it's back, I think. But yeah.
Did I? So did I need to do it all in one?
Sketch?
Yeah. One
No.
Art Studio because I did it.
Did it in separate part studios is fine.
Okay.
Yeah, that looks good. Okay. Bruh. Yeah, you're missing the line in the middle. So, line, yeah. Just do it out here for now because it'll be easier to see. Or yeah, never mind. Escape, L, or yeah, hotkeys are fun too. Yeah, good. Type 68 in. Because so when you see, or yeah, you can dimension it too. That works.
Zoom out until you can see everything.
Yeah.
Now, click right there.
Okay, Shift S for a point in, oops.
There you go.
Oh, yeah, hit X. Double click on your sketch again. Yeah, that'll work. Shift S. Oh, do you have weird? Interesting. Okay. Yeah, double click on the sketch. I guess your point hotkey is different. Oh wait, you're not editing the sketch. Yeah, there you go. Okay, now you should. Yeah, click on the sketch, or on the line. You didn't Shift S. You didn't have it. You didn't. You deselected a tool. Shift or wait. Here, can I just? This mouse is cool. Here.
What about the bottom right?
There. Okay, now horizontal. So H on your keyboard, or yeah. Nope. Control it. You have to hit the point, not the line.
Well, now you can hit this.
No, it's got to be here. H, the point in the middle, and then the origin, and then dimension this. Nope. The line. No, the one you just made. You have to hit the line itself, not the text. Escape. This. This one. 32. Done. Okay. Are we good? Yeah, mirror it again. Or you can, so don't delete it, just hit the mirror tool. And then select your mirror line as the middle, and then select that just the new line you made, and then you should be good.
Yeah, but this would violate.
How what? He probably didn't make it horizontal with the midpoint, if I had to guess.
Yeah, horizontal with that. Which way is it moving? Is it moving vertically?
Yeah, can he move it vertically or horizontally? If he can move it horizontally, he didn't dimension it relative to the thing.
You can still move it vertically, just you didn't.
Okay, does everybody here have something similar? Okay, I'm gonna. So that concludes all we need for this top-down sketch. So we're gonna exit this. We're gonna go here. We're gonna make a new sketch on the right plane. We're gonna make a circle. Circle's gonna be 104 millimeters in diameter. Still on the other thing? Okay. Yeah, sure. Okay, does everybody have a new sketch on the right plane? Okay, we're gonna make a circle that's 104 mils in diameter. This is the same as the. I'm gonna find it later. Yeah. Then we're gonna make it tangent or T on your keyboard with this light on the ground there. So this represents one of our mecchanum wheels. So we're gonna make a circle that's 104 mils in diameter. This is the same as the. I'm gonna find it later. Yeah. Then we're gonna make it tangent or T on your keyboard with this light on the ground there. So this represents one of our mecchanum wheels. So this represents one of our mecchanum wheels. No, this is just dividing the wheels, not the plate yet. We're gonna make a line Q up from here. Okay, so we're gonna make a line. So L on your keyboard or hit the line tool. You're gonna make a line up, and then you're gonna make it vertical with one of these points on the drivetrain here. And then once you have your line, you're gonna dimension, and we're gonna give, let's say, 2 mil of clearance from the wheel from the back of the plate.
Is that the midpoint line on the side?
No, it's just a line. Again.
Just a regular line that different.
Oh yeah, so I made it a construction because technically you don't need to do this here because this sketch isn't going to be extruded or anything. But normally it's a good practice. So this line is just to define something for us to base geometry off of. It's not actually going to be part of our sketch. Well, it's part of our sketch, but it's not going to be part of geometry that we extrude or do anything with. So if you hit Q on the line, it'll turn it into a construction, which basically means it's only there to define geometry and not there to define like an actual physical part of your sketch. So does everybody have one wheel, I guess, air quotes? Okay, okay, bruh. Yeah.
So how do I like add line like
L, draw a line.
yeah, and how
Yep.
do I like make it like
A dotted, a construction, or
yeah.
okay. So select the line. So just click on it and then hit Q. Now it's construction.
Okay. And
Just make it vertical. So V with this point on the bottom there.
wait.
V, yeah. So V,
Yeah, I pressed
yeah.
V and
Here, and that one, yeah.
okay.
There you go. And then hit T or sorry, no, never mind. Dimension that from away from the line, yeah. And then hit click again, and then hit 2, and then hit T and tangent to make this wheel hit the ground. Yeah.
Oh, so there and there.
Yeah.
Okay. Do I move the line down as well?
No, the line doesn't. The line can be wherever. Yeah.
So that's the construction line, right?
Yep.
So did you dimension that line?
And then okay. Oh, did I forget to tell everybody to make it? Okay. Wow. Okay, I'm just gonna go over this again real fast. So make a circle, 104 mils in diameter. Once you have that, you're gonna hit T or tangent up here. I'm doing it again. I'm just doing it a second time. Tangent on this line. You're gonna make line Q up from here. You're gonna set it.
Have this shape. Don't worry about it. He's just.
Yeah, I'm redoing it. Vertical with this point on the end there, and then we're gonna dimension this to be 2 mils away from the end of our drivetrain. Then you should have this. So everybody have this. Maybe kind of, sort of. Okay. spinny chairs are great. Okay, we're gonna make a second circle. This one's gonna be 37.5 mils in diameter. This is the size of a Go Build a Yellow Jacket motor. Yep. Okay. Circle, circle, circle. 37.5. Yeah.
Yeah, 3 of them are not cut off.
Okay.
yet, so-
You just need to. Okay. That doesn't need to have any. So vertical lock that to the end point of your drivetrain. Yep. Hit V. Yep. Okay. Now dimension. And then just make it 2 mil from this. Yeah, the end of that. Okay, you're fairly close here. Escape. So vertical or V. Hit the point on the bottom of your line. Yep. And the point on the end of your drivetrain there. Yep. And then, did you make this tangent with the ground already? The wheel? I think you did. It looks like it is. Okay, so escape. Dimension, or D on your keyboard. Hit the line, and then the side of the circle. Yep. And then type in 2. Once you click. Yeah. Click. And then 2. And then enter. There you go. Oh, wait. Here, can I zoom out? I think. Can you hit escape? It looks like you didn't define it as tangent. So T or tangent on your. Yeah, and then hit the circle and the line on the bottom. There you go. I think. Tangent.
Check if it is defined.
T. Click the circle and then click the line. Was? Wait. I think your line. Or here, can I just use the mouse real quick? Just escape for. What is not defined here? Oh yeah, escape.
Just drag it around because I know OnShape
Oh, I see what it is.
Oh, it's not a horizontal dimension.
Yeah, it's because you dimension from the point instead of the line. The point is undefined, so will the dimension. You see, so this point is undefined because we didn't give it a height, but that doesn't matter. But this line is not undefined, so there you go. It's like if you define geometry off of something else that is undefined, the geometry that's defined will be defined either. This was complicated. Should have just done like circles. Okay. Okay.
Trust, welcome to Global Robotics. How are you doing? Just give me calories in the world. It's gonna happen. You're gonna break the whole FTC system.
Yeah.
I mean, will you build a robot?
Probably. You could say, okay, just everyone just watch for now for 10 minutes. I'm just going to speed run the drivetrain.
Yeah.
And then I will help you guys build
Right.
it. That's it. And then we're done.
Send a recording, I guess.
I'm recording everything.
Okay.
Because then at least you have that on the recording.
Yeah.
I don't know if that's useful or not. We can probably stick around past 3. Like, no UFC people have come, right? So
Yeah.
So.
Okay. Does anybody else need help? You guys are good? Okay. If you want to try, you have the 37.5 circle. Try making 2 of them. Define like 2 or 3 mils in between the 2 circles. Make them symmetrical to the midpoint, and then mirror the wheel onto the other side. Okay. I think everybody's on the same spot approximately now, right? It's really specific about what stuff. Hmm? Yeah. Or yeah, I think so. Okay, is everybody on? Does everybody have this? Wow. Maybe I should have done something simpler than a drivetrain. Hmm? Yeah. Oh well. Too late now.
We made dice for our rookies. So that's what we do dice.
Yeah.
I can't say they turned out particularly well.
I was like, drivetrain is good because it's something that they could actually maybe use, but
Yeah. Well, I think that's true. It's like you need like the foundational skills.
yeah.
Yeah.
Okay. We have this 37.5 circle. We're gonna dimension it to be. Oops. What am I doing? 13 mils from the bottom of the ground plane, basically, is what this is. We're going to then mirror all of this and then set these to be 4 mils apart. Okay, so now we have the basically the defining geometry of our drivetrain, right? We have our two motors, our two wheels, and then the plates. 4 mil. Yeah.
13 from the ground and 4 from the
Yeah. E. Eh, 4 mil between the two circles, and you're good. Make sure it's the edges, not the centers. That's fine.
Click on the bottom
You should make it. It's 4. You want it to be 4 between the two circles, not 4 to the center. Also, you should mirror the other wheel. Yeah. Nice. Oop, there's a chord there. Yeah. Between the circle. Yeah, so click there. Yeah. Nice.
Maybe Raffles right.
Sorry, you just disconnected from me, so just maybe load.
Oh, okay. Well, yeah, it didn't crash, which is cool. Yep. Control Z. That means you overdefined something.
Do you want me to give a quick talk about order constraints? Or
Maybe, yeah. This is.
I can give it later.
Yeah, if you want to. I think this is okay. Why is there a hippo? That's a good question.
Hi. Don't set settings. So hover over the number. Actually, you're in a tree right now. So what you need to do
Your wheels aren't. Or something's weird here.
hover over the number and just
Oh, you define a bunch of stuff as 0. Okay, so.
set the number. Set to whatever.
Oh, sorry, I'm blocking. Yeah.
That's all right.
Go. So. Escape here. That should be 4. Yeah. Dimension. Oh wait, I hit D. Yeah. Should be 13. And then I think you didn't make these tangent. And you didn't dimension this from there. what is? Oh, because this isn't set to anything. Vertical. I'll also probably do like more of. I can, if you want, I could go over this design with like all of the ATA teams, probably. If you guys want. I don't know. You were doing programming, right? Mostly. Okay. Okay. Everybody have this successfully done? Okay. Now we get to make. We're gonna So this is what we like to call a master sketch. So this is like very simple but very definitive geometry for that applies to everything on the drivetrain. So this is something that we can use as a reference for kind of like what we want the finished product to kind of like fit inside and where we want certain key aspects to be. So generally speaking, if you're gonna do a master sketch, you want to keep it in its own part studio. So we're gonna have, because we're just making a drivetrain, this maybe seems kind of dumb, and we're gonna have like two sketches that are like, or two part studios that are very similar. But if you're gonna use this as a master sketch for like other features, it's nice to have it just be nice and uncluttered and just have the master sketch in here. So what we're gonna do is we're gonna make a new part studio. So you're gonna hit the plus down in the corner here, and then create part studio. Now you should have a new one that looks completely empty, except for your planes. You can go up here, find this derived tool. Click on the derived tool.
Wait, they haven't spotted derived.
If your laptop screen is very tiny or your UI is small, there'll be a hamburger menu that will have the derived tool in it. You can also use there should be a search tool feature. You can also use that and search for the derived tool as well. Derived, select Part Studio. You're going to select the Part Studio 1 and then hit check, and you should basically get a copy of it. So that's a kind of typical like master sketch workflow for parts. So you'll make a master sketch defining like certain geometry for something, and then each additional part you'll derive the sketch into and then use that as a reference.
Yeah. So when you're doing a derived part, you could have inserted a whole part.
Yes, that is correct. Yeah.
Maybe can you mention again why should I do all this instead of just running some wheels? Or like, what is? Just reiterate what the sketch is.
Okay, so the point of the sketch is to define like certain key geometry of your drivetrain and or like whatever part you're making, and it gives you kind of a reference for where stuff should be placed and kind of like a frame of like, oh, I need like this needs to be like smaller, like maybe we could fit something here. And it also gives you a reference that you can export into other documents as like a like, oh, this is our defining sketch of like where stuff on the drivetrain is, like how can I like add additional parts into it. Okay, does everybody have this second part studio with your master sketches in it? Yes. Okay. We're going to create a plane. So there's no hotkey for this. I don't know why. Wish there was. We're gonna plane. You're gonna select line angle, and then select your innermost plane here, or sorry, innermost line on one of your drivetrain plates, and rotate the plane by 90 degrees.
Wait,
Yeah.
it's lane. Can you?
Yeah, so plane tool up here. Select plane tool. We're gonna select from this menu line angle. Click on this inside line on your drivetrain here. And then yeah, 90 degrees, yeah. Boom. There's a way. Okay, does everybody have a plane there? Okay, no. Yeah. Hmm? Nope. You're okay. Here, if you search for tools, that's normally the best way. So search for plane. Yeah, there you go. So click that. Yeah. And then, so, no, the dropped, or here. So select your entity first. So select the line on the inside of that drivetrain plate. Well, it doesn't matter which order you do it in. This. Okay, so now change this from offset to line angle. Yeah, and then type in 90 degrees, and you should be good.
Select the line first. So you need to hit X.
You can select the line after.
Oh, okay.
Yours,
So
yeah.
select that one.
No, the inside one.
The inside
And,
one.
yeah. Plane help.
No clue how to use plane.
Line angle, and yeah, and then yeah, you're good.
Oh, what is this?
Select additional. What? It should be fine. Wait,
Yeah, just hit the X there.
why isn't it?
Pan around. So yeah, look
Or,
around.
yeah, rotate. Yeah, you're good.
Yeah. Don't know why it said that.
Yeah, just hit enter.
Or just
Or yeah, check or whatever. Something. Yeah. Good.
there you go.
Close that.
Art environment is where you more comfortably draw sketches and develop.
Yep. Okay, so inside line on this. Yeah, click that. Yeah, click line angle instead of offset, and then change it to 90 degrees. Yeah. And then check mark. Yeah. Similar question.
Where do I find?
The plane tool. Okay, so generally speaking, if you can't find something, use the search tool bar, but it's going to be in like this drop down or something, I think. Yeah, plane right there. So there's a lot of tools in the toolbar, and if your laptop screen is tiny or you have your font size set larger, it's going to hide some of them. Actually, I should just do this at the front. Yeah, if you're ever having trouble finding like a specific tool or something and there's no hotkey for it, generally speaking, if your laptop screen is kind of tiny, or if you have like your display settings set to something like larger or your UI enlarged, it's gonna squish some of the tools together and put them behind like drop-down menus. So you can always use Alt-C, or there'll be a little pop-up here normally to search for tools. The OnShape hotkeys are really stupid.
They are bad.
And like for example, like why isn't there a plane hotkey? There like none of these have hotkeys. Yeah, exactly. Why is there a midpoint line hotkey and
You
not?
understand why I just click the icons now?
Yeah, I have the sketch ones memorized, but not the other ones. Okay. Anyways, does everybody have a plane created now? Hopefully. Yes. Okay. We're gonna create a sketch on this plane. Big surprise. So we're gonna make our first drivetrain plate. So the reason it's called a parallel plate design is because we have a series of parallel drivetrain plates that hold together. They're held together by standoffs. In between the standoffs, we have motors, wheels, everything, and it kind of. Where's the? As you can see, it kind of ends up looking. It's kind of like a big drivetrain sandwich, I guess. We're gonna start making this inside plate here now. So. Spend a lot of look the hexagon too. Okay. So sketch, we're gonna start by making a couple. So we're gonna use the use tool. We're gonna grab the center point of each of these motors, as well as these wheels, and also the actual circles themselves from the motors. U on your keyboard, or the one that says use tool up here.
Project convert.
Yeah.
It's a funny sentence.
Okay. Once you have those two circles, and here we're gonna make C. Also, yeah, C for center point circle, or click on the circle icon. Make a circle. Dimension it to be 4 mils. Make a circle over here on. I guess we could mirror it. we'll just do one side. Okay. Now that we have this, we need to make a couple other adjustments. So we're gonna make a circle down here, circle up here. We're gonna use the equals tool. So E on your keyboard. Select this circle, and then the inner circle here that you've dimensioned to 4, and then that circle as well. All of the circles from the previous sketch. Okay. Oh, dark mode is so bad on this. Right. So lock to right view. Did you use the outer circle? You only want the center of these. Can just escape and delete this sketch, and we'll start again. Okay. Sketch. Select plane 1. Yep. U. Okay. Middle point on that. Yep. Circle. Yep. Circle. Middle point. Okay. Now C on your keyboard. Circle there on the center of that wheel. That's 4 mils. Just type 4 in your keyboard. Yep. Enter. Yep. Okay. Circle up here. Anywhere, it doesn't really matter. Circle down there. Okay, equals E. Yep. And make all that circle and then circle inside the wheel. Yep. Yep. And that one. Yeah. And then the middle one and the other circle. Yep. Okay. Everybody good? Equal. So E or equals, and you'll make them the same as the 4 in. So this is just to avoid having a little tiny 4 next to every single circle that we put on the plate, because it's really painful. And the other reason we do this is, let's say you want to change all of the holes on the plates to be like 4.2 for clearance or something. Instead of having to type 4.2 into every single circle, you can just type it into this one, and it'll update all of them. Yes. Variables are more complicated though, and I don't want to like also make variable studios at the moment. Yeah. Vertically, you're one step ahead of me. But yes. Yep. Okay, there's 2. Yep. Just click here to reconnect. Oh. Here, do you want me to just catch you up real quick? Do you have the second part studio with the derived? Okay. Here. So we're gonna go. Part studio. I hate drop down menus. You got a question? Yeah.
Are these circles made anywhere in particular?
Yeah, we'll define them in a second. Sorry, yeah. You're good? Or
No, she doesn't have that.
the circles?
2 circles.
Yeah, okay, so C, and then just make 2 circles on the outside. We'll define them in a second, and use the equals tool to make them the same dimension as the one that you just made 4 mils. Or you could dimension them 4 mils separately, but that'll be a little bit. Yeah. Maybe I should just zoom in for the sake of all the other people. Because that's really hard to see, isn't it?
The other two holes don't need to be dimensioned anything further.
They just need to be equal to the one in the middle. Yeah. I guess that doesn't really help, does it? If I zoom in. Yeah, this is fine. Okay. So everybody has the thing. 2 circles. These we're going to use vertical or V on your keyboard. Make those 2 circles vertical to each other.
Make sure you click on the centers.
Yeah, the centers and not the sides. Well, will it even work on the sides? Yeah. Hmm?
We're trying to guess why it looks a little wonky, but I think it's just.
I guess the projector.
It could be the screen too.
Yeah, the
Like-
screen's.
I think the auto keystone is like real close, but not 100%.
Okay, then we're gonna go over here, hit this drop down menu, and select center point arc. Yeah. Okay. Does everybody have the center point arc tool selected? Okay, once you do, I'm gonna go here. We're gonna give it a radius of 4. And we'll do the same on the bottom one. We'll draw a line using L on your keyboard or between the 2. And then we'll make it coincident or I on your keyboard with this line here. Oh. Maybe. Yeah, 1 of the points. Yeah. Wait, why does that make it sad? Interesting. Okay. And I'm gonna go help some people. Or yeah. Well, yeah, let's just go. Does everybody have something that looks more or less like that? You need to go. Yeah, you drew your line. Yes. Oh yeah, I forgot. Okay, I forgot to mention because it did it automatically when I drew my points. Okay. Make sure when you draw the center point arcs that this point here is defined as horizontal and the top point is defined as vertical relative to the center of the circle. Yes. Yes. Here. No. You don't need it here. Vertical. Hit this one on the side here, and that one. Yep. And then. Oh, it's defined as horizontal. Escape. Hit. Click this here. That. Yep. And then hit delete. Oh. Okay. Control Z. Twice. Drag this point up. Yeah.
Should the bottom arc be tangent to the floor?
No. I will do that in a second. Here, can I do? We're just gonna delete this and go again. Okay, so when you do center point arcs, they really like to automatically define to certain points. So we're gonna go like this, and then like that, and then we're gonna go say vertical here, horizontal there, I this on this line here. And then I think this probably automatically, yeah, you see that? That means it's defined as horizontal already. So OnShape likes to define stuff when you like drag it, when you make it. So there you go. Should be good.
Do I need to make the other part
We'll get there. Or I think you're good now.
Yeah.
Yeah. Okay. Same thing with you. So, oh, you don't have a trackpad, do you? Or you only have a trackpad and no mouse? CAD with trackpad makes my soul hurt. Okay, so
a mouse in my Mac had a USB port.
it doesn't have a USB port.
No, Macs don't have it anymore.
That's the most Apple thing I've ever heard. Bro.
Yeah.
This is actually so painful. Okay, can you do the same thing to the top? Ah.
Wait.
Okay. Define this point as vertical with this hole, and one second.
I just placed a point at the top.
That's gonna. Actually, that's probably fine. You can just make weird. Yeah.
How do I do that?
Arc. Click center point arc. Yep. Click on the middle point there. Yep. Drag to the left, or yeah, drag up. Yep. Click. Drag to the left. Click when you see it lock horizontal. Yeah, good. Okay. Vertical. Lock this point vertically to that one. Yeah, that. Yep. That one. Yep. Dimension the arc, the diameter of the arc to be 4. 1 second, I'm gonna help her. Yeah. Okay, you did the same thing. A bunch of people did this. Can you hit escape for me? Okay, so you see how this is horizontal? We don't want that. Oh, what the heck? Oh, you made 2 arcs. Yeah. This one. Okay. Yeah, you made 2 arcs. This is your problem. Okay. This is gonna go here. Escape. And then out that. There we go. Escape. Yeah. Okay, now we're gonna hit dimension or D on your keyboard. And we're gonna dimension the radius of that to be. Oh wait, escape. D again. 4. And then same thing up here. Yeah. Escape. Line between the two. No, this is. Yeah, and then okay, there's a couple things wrong here. Escape. So tonight, or that's weird. Wait, does one of these points? Okay, dimension the radius of these to be 4, and just the bottom one, I think, and then. That'll work too. Okay, I think you're good. Okay. Whoa. That looks entertaining. Are we sort of kind of good? Maybe? Wow. Yeah, okay. Okay, is everybody here? Maybe kind of sort of? Oh, okay. But he looks good. I think everybody's good. I think. So, next thing we're gonna do, we're gonna dimension the bottom of this arc. So this is the bottom, gonna be the bottom of our drivetrain plate to be 10 mils off the floor. generally speaking, in terms of drivetrain ground clearance, 10 mil is as low as you want to go for games without any obstacles on the floor. So, tile sync on FTC tiles is generally anywhere between 3 and 5 millimeters, depending on how heavy your robot is. On this robot, it's about 3 mils of tile sync. So we have 10 mils of ground clearance on hard ground, but when you put it on the field tiles, it actually becomes 7. I have seen teams get away with like 7 or 8 mils of ground clearance when not on foam tiles, but I would strongly recommend not going any lower than 10 millimeters. We're gonna dimension between the edge of the wheel here and the edge of the standoff, or this circle here, to be 8 millimeters. Then once you have that, we're gonna make 2 more circles. Make the circles equal to the middle one. And then horizontal with these guys. And then vertical with each other and 8 millimeters away from the wheel. Okay, that was pretty fast. So
That circle dimension from the big one is from center to edge.
edge to edge. The 8 mil, yeah. Okay, once we're done that, we're gonna go. We'll draw 2 lines, one from the top of this arc to the middle there, and one from the bottom of this arc to the middle. Yeah.
If you've mirrored
The
edges before,
yeah, just do the
does
line.
it go crazy? No, it doesn't mind.
No.
Other one.
You said a 10-inch from the
10 mil, but yeah.
Like, so we're gonna like
Yep.
having 8 millimeters off. My line like
Yeah,
goes
it's
through the circle, but like it does not.
oh here. Click the point on the bottom of this arc. No, the one on the left there, and then hit this line. Yeah. There you go. Okay, and then
It was I do.
I is coincident, so that means like on top or like the same. Circle over here. Yeah, 2 circles. Make them the same size as this. Make them horizontal. Yeah.
So like this.
Yeah. Okay, so now you're gonna want to. Oh wait, 1 second. I'm coming around. Doopa-doopa-doo. Okay, you're gonna want to go. Why is there a line in here? Oh, did you mirror? You mirrored it?
Yeah.
Okay, so you might run into issues with that, but let's see. So dimension. This is supposed to be 8 mil away. There's probably like 20 different ways to get here, at least.
And mirroring.
Yes, mirroring works. Actually, this is probably easier than the way I did it, but it's kind of like, yeah, this is cool. And then from here, see if you can get mirror the same geometry onto the other side,
So
and
I
then
should mirror this through the middle.
yeah, mirror it through the middle, and then draw lines between the top of the thing, so you have a full box. You forgot to dimension something, I think, or several somethings. Oh god, this one might hurt me. What team are you on?
FTC.
Yeah, FTC.
I'm in Vex right now.
Oh, you're in Vex? weeks. Oh shoot. Okay. Oh, you were the guy that applied.
There was supposed to be a
Oh,
mirror
yeah.
here. You
Yeah,
see
okay.
this hole here?
Have you done programming
There's
before?
supposed to be a hole
Programming?
in the
Not
middle of
really.
that circle.
What's your
It's
favorite CAD
supposed to
software?
mirror the
Fusion, Sci-Fi.
Fusion. Another one of those guys. I'm kidding. Fusion's probably easier to learn than OnShape.
Yeah.
They're good for
Do you only have click to select?
mirror to the
Oh, wait, you did dimension this. Are you in inches?
Millimeters. Well, I guess it's inches. But
Your
like
your workspace is in. Okay. Oh, this is what you forgot to do.
You're supposed to
Bruh.
hit on the mirror so you can select what your mirror need to go.
There we go.
Oh.
And then you already did it.
Wait, we have to make the
It was I.
We have to make the. What are the lines going to?
They're going to the middle. We're gonna mirror it, and then we're gonna have a full plate.
Okay, wait. Do I need to put arcs for these circles?
No.
No. Okay. Let's just delete that.
Yeah, mirror. Yeah.
So you draw a line here, right?
Yeah, you could mirror it. I'm doing it a slightly different way, but yes, mirroring it would also work. So you need to. Yeah, you have a line in the middle. Yeah. Mirror. Yep. Perfect. Good. That's because it's already 8. It's already defined, I think. Escape. Escape. Yeah. Dimension. You want to do this top one to be 8, and then I think you're okay. Nice. Oh yeah, you already mirrored it and everything. Yeah, that looks great. Do you want to try extruding it into a plate? Or actually, I'll just go over that real quick, and then yeah. Okay, is everybody more or less there? You're good. Yeah, we're about to yeah. Okay, so next step we're gonna mirror everything we just did around the midpoint. So we have mirror this line, everything, and now we should have a full drivetrain plate. So, dang, we only have half an hour left. Should I do well?
I think just finish with 1 or 2 plus.
Yeah.
So, Adrian, what I would recommend is you can speed up a bit and just tell people you have at the end of time remaining, just to get finished what you want, or you can be happy with only getting halfway. It's gonna have to.
Okay. Do you want me to do?
Probably take a poll, maybe ask how would we like to rush.
Yeah, sure. Do you want? Okay. We're probably gonna run out of time and not be able to finish this. So if you want, what I can do is I can run through this like really fast, and explain it like kind of briefly, and you can rewatch the Twitch thing at home and finish the drivetrain properly, or I can walk through step by step and we can do like probably only like 1 or 2 more like this plate and then the motor mounting plate, and that would probably be it.
Okay, so who wants to do speed run and see Adrian finish this so that we can at least see how it's done, and then you can, like I said, you can rewatch the stream after. Sure.
Okay, that looks like what we're doing. Okay. Okay, so right now I'm gonna do.
Yeah, just sorry, one quick thing. Yeah, try to keep up, and Adrian and Sheldon can help me kind of as we start wrapping up. Theoretically, we have this room until 3 p.m. only, but we can stay a little bit longer if the room takes. All right.
Right now what I'm doing is I'm gonna be doing our mounting holes for the motor mounting plate. So it's probably a better way to do this, but i.e. patterns. I love rectangles. Don't need those because I can mirror them. Okay, so we're gonna be using square beam standoff. So this is actually gonna be a through. Forgot to do one up here too. This is actually gonna be a through, like a standoff that supports the entire drivetrain. But the motor mounting plate is gonna rest on it. So, oh, I don't need to do that line yet. Never mind. That'll be on a different part. Horizontal here. Okay, we're good. Why does the mirror one not have a hotkey? Like, please. Yeah, it literally probably does in every other software. Okay, so that is our inner plate done. Shift E, boom. Hello? Hotkeys? It doesn't work. Okay, yeah, it looks fine. 1.8 or 3.175 mils. God, I hate OnShape's basic colors are pretty bad. Okay, so that's one plate done. So inner plate here. Next one, I'm gonna make 2 planes at once just for speed. Line angle 90. Done. We're gonna make another plane for the outer plate. Line angle 90. Done. Okay, the outer plate is going to come together really, really fast since it's literally just a copy of the inner plate with slightly less holes on it. Plane 3 was messed up. What did I do? One of these is... Wait. No, plane 2 is wrong. Aha. 0? Okay, that's strange. Okay, sketch on plane 3. Going to use the use tool here to grab all of the standoffs we want on the outer plate that go through. So it'll be those 10. These 5 here are for the motor mounting plate, not for the outer plate. So we go there, extrude this sketch, and then that's our outer plate done. Oh wait, I forgot something. We're gonna want circle 8. This is for the clearance for the motor shafts. In there. Nope. Here we go. Okay. Yeah, true. Okay. So that was the use tool basically exclusively, and then I made 2 circles which were coincident to the circles on the motors. If that makes vague sense. Just gonna hide the outer plate for simplicity's sake. Sketch on this plane 2 here. I'm gonna use these line. Wait, are these square beams? They're 8 mils thick. Okay. 8 mil. What happened to my... There we go. Okay, what? Fine. We're gonna go with a point that's, this is messy because that, a point that's in the center of that, and then dimension this line to be, 4 mil above that. this point. If you really want to get fancy, I'll make Sheldon cry by adding a sketch fillet. Then we're going to mirror around this line, mirror everything we have over here, including this line and this sketch fillet. The sketch fillet is completely optional. If you don't want to use it, just draw a line between the 2 points. I'm using it so that the machinists don't cry when they see this part. Now we have that. We're going to center point circle here, make it equal to these. This is another tool that's really useful. We're going to use the linear pattern tool. So this lets you make multiple instances of sketch geometry in kind of like a repeating pattern. We're going to do 16 mil hole pattern because that's what Go Build a motors mount on, like this. And then this is a cool way to do this. We're going to do Shift M or midpoint and select these 3 points. And that will lock it to the center. Yeah, that's way easier. You could also do it by making a line and then putting a point in the middle of the line and then locking the line to that, but this just kind of shortcuts that and gives you the same result. And then we're going to mirror this as well because I forgot to. Hello? Oh, I didn't select a mirror line. Here, select this. And those. Okay, so now we have a motor mounting plate. So we're going to extrude this. That is going the wrong way. 3.175 or 1/8 of a millimeter. Or yeah, 1/8 of an inch. Sorry. Oh, I always forget this. These also need a circle here. It needs to be 8.5 mils. Coincident on that point, and then equals. Okay, there we go. So that is our 3 drivetrain plates done. So before we go into an assembly, we're going to need a pulley to run our belts with. So this is going to be belted out to here. So we're going to need to make, I'm going to make a new part studio here. I'm going to call this pulley. Okay, in here, what we're going to do, we're going to derive something. So we're going to, where does derived go when it disappears? My UI is small. Derived, select part studio. I'm going to go other documents, copy of, it'll be on our website if you haven't made a copy of it, but this parts generator, I'm going to go grab a copy of this pulley. We want a 24 tooth HGD5 with a 9 mil belt width, round bore 14 mil. Generate that. Check. Now I have a pulley in my part studio. We're going to extrude this. Oh wait, no, we don't need to do that yet. Okay, I'm gonna make a sketch on the bottom of this pulley. We're gonna make 4 like that. We're gonna do linear pattern on this guy. It's gonna be 32 mils this time. This is for the mounting pattern of a mecchanum wheel. 32 mil. 2 times. Done. Same thing, midpoint or Shift M to center it like that. We're going to do another center point arc like so. Radius on this will also be 4. I'm going to make a construction circle here. It's coincident with that point there. We're going to make a point, nope, not there. Point horizontal to the origin that is 4 millimeters in here. The reason we're doing this whole thing, give me a second, we're going to go line there, and then we're going to make it this line tangent with this arc. The reason we're doing this is when you mount this pulley on the Gobilda mecchanum wheels, they have 4 sets of screws that hold the mecchanum wheels together, and we need to avoid the pulley. If the pulley just went straight down, it would collide with those screws when we put it on the mecchanum wheel, so we need to add this just to avoid hitting those screws when we attach the pulley. You'll see when we make the, nope, not that. You'll see when we go into the assembly here. Hello, Shift S, make a point, dimension it to be 4 away, line from here to there, and then make that tangent with T. Okay, now we're going to use a circular pattern. So we're going to, how do I have to use this? Use the origin just so we have it on our sketch. We're going to select circular pattern. We're going to select the origin as the center. We're going to select all of this as our stuff. We're going to make, to copy, we're going to make it 4. And now we should have that. We're going to go drag this away. Now we have this, which is the basis for the rest of our pulley. Done here. Extrude this sketch. Other way, we're going to go 11 millimeters, like so. Okay, now we are going to make sure this bore goes all the way through. It's arbitrary, doesn't really matter. We're going to make a sketch here so we can put a bearing in the top of this pulley. Oop. Circle on the center of that, make it 15 mils in diameter. Extrude. Sketch to remove. We're going to go a depth of 1 mil into this part just for the flange of the bearing there. Okay, this looks good, but we do have an issue. If we put screws here, they're going to collide with the belt when we have it, so we need to recess an area for those. So we're going to make a sketch on that surface there. Make this 8 mil circle, or make it coincident with the side of that. It's kind of up to you. I'm just going to do a linear pattern because it's faster. 2. And this will go the other way. -32, and then check. Should be good. Shift, extrude, sketch 3. We're going to remove. We're going to go 4 millimeters this way. We're going to say second end position and just take that off so we can fit the screws in here. Okay, now this looks pretty good, but we have these really ugly, super pointy corners here, which aren't going to print super well in our 3D printer, so we're going to fillet those. Here, we'll do a 2 mil fillet radius is good. While we're at it, we're going to fillet down here as well because it looks nice. Also, because overhangs are gross, even though that's like a 1 mil overhang. Okay, once this is done, that is, don't select the face. That is our pulley. Don't select the face. And yeah, that looks pretty good. So this is our pulley. So pulley here, master sketch, drivetrain plates. In here, if you want to, we can do a mirror in the part studio. Entities to mirror, we will select all 3 of these parts, and our mirror plane is the right plane, and then we will have drivetrain plates on either side. Okay, now we're going to go into our assembly and start assembling half of our drivetrain pod here. So I'm going to grab 1 of each of our plates. I'm going to grab 2 pulleys. going to insert motor. I guess I should use simplified motors. We'll do that later. Structure, standoffs and spacers. We're going to insert one of these. We want square beams, don't we? Beams. This beam. Okay, we're going to reconfigure this to be a 7-hole beam. And we're gonna, why is this missing? Oh, oops, I messed something up on one of the plates. Sketch 2. I forgot to use these corner holes. And also these ones. Assembly. That looks good. Okay, we're gonna mate this. Oh, that to the outside here. Okay, then we're gonna use replicate. Select this. Select match individual edges. Select all of these. And this one. Good. Then we're going to mate this outside plate here. To that. Okay, starting to look kind of like a drivetrain. We're going to configure, change configuration on this. We want 56 mil. Select that. And select this. Same deal, we'll replicate this here for our other drivetrain wheel. Okay, now we need, gonna need, oops, structure, where is it? Nope, not that. Standoffs and spacers, need one of these. Change configuration, we're gonna make this a 32 mil. Yep. Mate that to here. Yep. And then we're gonna replicate that as well. Okay, that looks good. Next, we're gonna do insert. I'm gonna go other documents here, here. This guy, we're gonna grab a assemblies. We're gonna grab a simplified go build a motor. Grab a simplified grip force mecchanum wheel. We're gonna need 2 of these. The reason we need 2 is because mecchanum wheels have 2 different slants, so they have to be 2 different parts, because I can't. Change configuration. Change this one to a right slant. Next, we're gonna put the pulleys on. So this guy on here. Do this. Okay, my laptop's dying. We're going to offset, rotate around Z 45. this one mate here. That flip. Nope, wait. Oops. Mate this with this here. Cylindrical? Yeah, or I can just rotate it by 45. Yeah, I guess you can do cylindrical and then like yeah. Yeah, they're kind of annoying sometimes. Okay, now I need to remember which way is up and which way is down. We're going to insert some bearings, which I think I have simplified versions of somewhere. Nope, not there. It's a utility. Nope. Yeah, these. I'm gonna grab one of these. I'm gonna put bearings on inside here. We're gonna mate that with this. Done. Gonna hit replicate. On. Oh. Bruh. Okay. Replicate. Why did it get rid of it? Replicate this. That. Match individual edges. We're gonna go here. We're gonna go here. We're gonna go here. So this is a dead axle drivetrain, which means the wheels will rotate on bearings, not the axles. I find this is just a little easier to build because you just need to screw the axles in instead of like putting them in bearings and then constraining them with like washers or something on the end. And this runs a lower risk of your like washers coming unscrewed when your wheels are running. If you have a live axle drivetrain, I've seen like washers or shaft collars come off of those, and then your wheels will fall out. I'm gonna mate this. Just go in here, there. Everything looks good. Same over here. If you really want to get picky, you probably want to throw a shim in between this and the wheel and the drivetrain. Oop, that one's got to be flipped around. Yeah, there we go. Okay, now we need to do motors, so we're going to reconfigure this. This is going to be a 435 RPM motor. Is 24 the short? Yeah. We're going to mate that with this. 1, 2. We're going to replicate that. Match individual edges. I think it'll be... Oh, wait, I did something wrong. This should get flipped around. Like that. There we go. Replicate. Actually, no, we're just going to insert another one. these, and we should be done. So we're gonna insert from here. We'll build a motion. I'm gonna finish it at exactly 3 o'clock, aren't I? Nope, not that. Not that. This one. Two of these. Oh wait, that's the wrong one. Oh no. Yep. Two of these, and then made that to there. Other way. Done. Made that there. Good. Nope, not good. Flip that. Done. And there we go. Excluding belts, we have a drivetrain. Dang it. Okay. Some other stuff. So this is. Yeah. Anybody following? Okay. So that will all be on Twitch. Dad can probably email a link out with that. Couple things to note. So I'll also in the email I'll attach at the end of this slideshow I have a couple challenges for like what you can add to the drivetrain to improve it a little bit. So some stuff that you can try on your own. I also have links to our how to make your own magnetic robot signs like we have on this guy. So linked document is the signs that we used on our robot. This is a really good one to like kind of just improve your like sketching skills with. It's pretty easy and you can make it fairly complex. It's also something that you can definitely use next season. So yeah. In terms of like improving on this drivetrain design, I'd recommend you need to add, like this is half of a drivetrain pod. It's missing cross bracing. So on how to attach it to like another version of itself. It's really season dependent how you want to cross brace drivetrains. But generally people will do it with U-channel and like 2x1 block mounts, which you can find on GoBuild. There's GoBuild's website. There's a couple other resources and tutorials that I can link if anybody's interested. But yeah. Yes. So pocketing or like lightning or I don't know, venting, there's all kinds of different terms that people use for it. As you can see, these plates are not solid plates. They have a bunch of material removed from them. So this is what's known as pocketing. Essentially, the best way to do this is you're going to use this lighten tool. There's a link to it on our website. You can find it there. This tool, what it allows you to do is you'll make a sketch where you basically play connect the dots. Where is it? Yeah, so in this sketch, you can see I've made a sketch and I've basically connected all of the holes on this belly pan that need support from, so these lines will essentially represent a strut of material. At the end, when I'm done, I will use this lighten tool. I will select all of the regions we want material removed from. You can select the thickness of the walls, the tool radius, so this matters for like what you're machining it on, and then you'll end up with something like this. Does that kind of make sense briefly? Do you want me to do a brief demo? I did a brief demo over lunch with some people. Do you want me to I'll just do a brief demo. I'll pocket one of these drivetrain plates just super quickly. So we're gonna make a sketch on this outer plate. Line tool between the center here center of all of these circles. And then, do that. Never mind. Doo-ba-doo-ba-doo. Oh. Yep. Yep.
How did you find out all the measurements for how far apart stuff should be?
Okay, so this I have a little sheet here, but basically all of this I kind of have memorized. I've done like a bunch of these drivetrains, so I know a lot of the stuff. A lot of it, almost all of it, is off the Go Build a website. So looking at like how big parts are, so that like 16 mil hole pattern. The other thing that I do, so whenever you saw me use a radius of 4 on something, that's to do with how big the screw heads on an M4 screw are. So if you look, here, I'm going to turn on the lights. If you look on the drivetrain okay. If you look on the drivetrain on this robot here, you can see that the screw heads line up exactly with the edge of the plate. So if you do a 4 mil radius, you'll end up with the screw heads lining up exactly with the curvature on the plate there. So that's intentional. That's why I'm using that. All of the other dimensions are driven by like kind of like a tolerance. So that 2 mil away from the edge of the plates was just to keep the wheels from contacting other robots, like outside the side of your drivetrain. The 3.17 mil that's a 1/8 sheet metal. That's like the most common sheet metal that people will cut plates out of. In terms of other dimensions, like that, all of the circle dimensions, the 96 mil that was represented a mecchanum wheel. Find that on the website. The 37.5 for the drivetrains. That's again that just you can find that on a technical drawing on their website as well. And then almost everything else, like the 8 mil clearance from those wheels, that's honestly a little bit big. You could probably cut that down to 6 mil clearance. Between that, I just wanted to make sure that there's no collisions happening between the edge of those square beams and the wheels there. And the reason we're using square beams instead of the circular standoffs on this drivetrain, first of all, these suck to tighten screws on because there's nowhere for you to, like, you can't put a wrench on it or anything. You basically have to grab the round standoff with a pair of pliers and then tighten the screw in. The other reason is it's impossible to mount. Well, it's not impossible. It's very difficult to mount like a plate or something easily to the front here. But with those square beam standoffs, you can just put holes in it and screw it in. Here, I'll just real quick finish up like this half of the pocketing. So, as there we go. Okay, so you can see I kind of played like a bit of connect the dots here between these points here. I'm gonna find my lighten tool, and I'm just gonna select the regions I want material removed from. Hit check mark. Oh, I forgot
Adrian,
one.
some people might have to leave at 3, so can I just do a couple bookkeeping things? You can keep working if you want, but so thanks everyone for coming out. We hope to do some more things like this, whether that's programming or more CAD or just FTC design and strategy stuff. So I guess stay tuned to our social medias and to ATAA in general.
Maybe we'll do the next one online. Just
yeah, we might have
easy.
like just online ones, or maybe a little easier for people to attend. So yeah, feedback's totally welcome. Carter here is one of our other team members. He has made some keychains for Worlds, so please everyone grab
take
one
keychains.
keychain. It's a miniature version of our robot. And yeah, if you guys have any questions, come ask us.
Yes,
Adrian will keep
please.
working here for a second, but I'm going to start having to pack up here just in
Yeah.
case UFC kicks us out.
The other thing, if there is interest, I would like during the off season on like say like a weeknight, I could run like 2 hours of like online like come ask me about your CAD question, like stuff if that is of interest to anybody. If I'm always open, like I'm on the First Alberta Discord if you want to like send me a message or whatever about like please help me with this thing or like I have a question about your robot or whatever. Send me an email as well. Anything, yeah. I'm happy to help with anything at all. So Also, if you have questions like right now, like please come ask.
Big
Yeah.
thanks.
Exactly.